It's 1:05, and so we're already 5 minutes late. Sending you good. I'm Greg Parsons, and I am the chair of. This is, you guys don't know, but this is, you may not know, this is the inaugural University Research Symposium, and this was something that was proposed by Research Administration and taken up, and by the University Research Council, and taken up by the Research Leadership Academy as an activity that we should do on campus. So the Research Leadership Academy, you'll see, is, anyway, I am the chair-elect of the Research Leadership Academy, which means that I am the chair of this symposium for this year. So we had to kind of kickstart this to get it going, and I'm glad that you guys, that everyone is here and participating, and we'd like to see this as a continuing event moving forward. So this is the purpose. The purpose really, in so many words, is I think that the RLA would like to, not just me, the whole RLA would like to propose and to promote more of a research community on campus, where people know more about what their neighbors are doing in the building across the street or building across campus. That's one of the frustrations that we often have. I hear many of my colleagues say, I know more about what my people are doing, my friends are doing in California or in Europe, and I don't know what the person sitting in the office next door to me is doing. So this is kind of an opportunity for us to share with our neighbors on campus what we're doing and see where we might find some opportunities to build some new bridges. The other thing that we've noted is that if you think about the progress and history of science, very often really big advances happen not in certain disciplines, but at where disciplines come together. So the opportunities for growth really are where disciplines come together, and so that's an opportunity for us here to meet people in different disciplines and think about ideas. What are you doing? What am I doing? What are you doing? What could we do together that would be more than just what I could do or what you could do together? So that's really the purpose of this event. These are the committee members. We've had a group of committee. Is anybody in the committee? You want to stand up? Or just raise your hands. How about that? Many committee members are here, and thank you. So many of these committee members, not all of them, but many of them, are also members of the Research Leadership Academy. So I'd like, if anybody in the Research Leadership Academy is here, so you can see around people in the Research Leadership Academy, they're sprinkled around. So Rob over here is our current chair, so say hello to him. He's been instrumental in this. The other thing that is also, is not listed up here, is Laura. Where's Laura? Laura has really run the show over here, and she's back figuring out the lights. She is a research program specialist, and she is the one that you've been getting a lot of emails from and whatnot, and she has been a tremendous help in this. And where's Genevieve? Genevieve is the Assistant Vice Chancellor for Research, and she has been also instrumental in pushing this forward. So thank you, Genevieve and Laura. So the other thing that's happened, yes, let's have it. Good, thank you, Genevieve and Laura. The other thing that's happened over the past year or so is the Research Administration and the faculty have been meeting to discuss how do we think about research on campus, and can we think about it and line it in terms of certain theme areas. And many of you have been involved in this discussion. I know that I was at some of the meetings involved in that. And these are kind of the strategic research areas that the university has defined as part of how we define ourselves moving forward. And you can see that there's some, they're very broad, in some cases very vague, but that's kind of done on purpose. And you can think of yourselves as maybe fitting in, your research fitting into more than one of these areas, or maybe you define the research you're doing squarely in one of these. But this is kind of a way that we might think of to draw people together, you know, who's working in what area, and it might be a way to help with the connectivity on campus. And you can also see there are definitions, and I won't read these. These are actually on the handout, the little square thing that's handed out. And I have here, this little square thing, it has the definitions up there, so if you want to read them. These have not come down from above. These kind of filtered up from the faculty. So this is your colleagues and your cohorts worked together in committee meetings to bring this together. So this is, you can think of this as ground up, bottom up kind of organization. So this is how we're gonna run the agenda. We are almost right on time. I'm supposed to give the introduction up until 1:10, at which point Gavin is going to present. What I'm going to do is, where's Allison? Allison is going to come up, and Allison Wilson is a member of the Research Leadership Academy, and she has volunteered to be the moderator for the first half of the session, up until where we do the break and the poster session. So we're going to have two presenters, actually three presenters, right? We're going to have Gavin, Vina, and Ralph, and thank you for coming. And they're going to present. We have a timer for 16 minutes, after which they will stop, and after which Allison is going to stop them hard, and they are going to get 4 minutes of questions, and then we're going to move on to the next speaker. So, and then we're going to have the lightning rounds, and the lightning rounds, you all that are presenting posters, you get 2 minutes. And so then we're going to have the break, and we'll go on to the next session. So any questions, any concerns? Did I miss anything? Did I cover everything? Something I think I should have said. Anyway, okay, Allison, would you please come up and introduce our first speaker? Thank you, everyone.
So good afternoon, everyone, and welcome. I'm not sure I'm actually going to jump up and drag them off the stage, but anyway. But if you're trying to figure out why they keep looking right over here, that's where their timer's running. And so for those of you who are doing the lightning talks and got told to meet Laura to prepare for that, this is Laura. And so for those of you all who haven't met her, and so hopefully, are we about ready for Gavin's talk? Yes. Fantastic. So I want to introduce our first speaker of the afternoon, and our first speaker is Gavin Smith. Gavin is a professor of landscape architecture in the College of Design. So.
As you get that set up, actually, I learned this is a penalty for not following instructions. I thought I had 20 minutes, so I'm going to adapt as we go. And also, I may get the award for the most recent faculty member here. I've been here since January, so I'm not sure if that's why I'm going first, but we'll see how it all pans out. And I will tell you just very briefly about a third of my career has dealt with working in government, working in the private sector, and the last 12 years at the university. In fact, the other university, I've been at UNC for the last 12 years. And I'm going to tell a story about some of the work that we did following Hurricane Matthew that really precipitated me moving here, in large part because one of the things that I was asked to do, which I'm going to advance through kind of the story of who I am, but I was asked by the governor and the director of North Carolina Emergency Management to put together a team that focused on 6 hard-hit, low-capacity communities after Matthew. And I was reaching out to both UNC and NC State, and I was able to identify about 8 or 9 faculty at NC State and one other colleague at UNC that was willing to work with me on this task. And that was really powerful to me because this is kind of one thing led to another, and ultimately was asked to come here, which I'm really pleased to be here because the issues of the true linkage of research, teaching, and engagement, it was stark in terms of the difference, in terms of the willingness of people at NC State to work with me, and I'm just so pleased to be here. And I'll talk a little bit about some of the things I'm doing more recently. So there's a list of some of the funding sources. So the legislature, Department of Homeland Security, and others provided substantial research funding for me and a team to build a team that was really looking at how do we address needs that weren't being met by these 6 communities, that weren't being funded by traditional post-disaster programs. If you're interested, just for the leave behind, if you look at either the Coastal Resilience Center or the Coastal Dynamics Lab, that has a listing of all of our work, which is really pretty extensive. And I should say the reason for the slides, the mix between NC State and the Coastal Resilience Center, I was the director of the Coastal Resilience Center until I chose to move to NC State. These are just some images of some of the students and faculty on the students and faculty a lunch meeting. At the top, just a cluster of students that I was working with. We were co-located in what's called a disaster field office with FEMA and North Carolina Emergency Management for almost a year and a half. So we sat with them in their building, which was really a powerful experience for the students. Just a few, those students have all gone on to graduate. One is getting his PhD at MIT. Another is a special advisor to the deputy director of FEMA. One is working for North Carolina Coastal Management, for example. So they've really got some some great jobs. And I'm going to talk more about some of the student experiences as well. And one of the other things that was able to do is to link this up with work that's already being done in North Carolina State University's College of Design. They have design workshops which really tackle some of these types of issues, and the information we glean from those workshops were fed right into the work that we've been doing throughout the week, or throughout the year, I should say. We also, I'll talk briefly about a Princeville workshop, Princeville, North Carolina, the oldest African-American community in America. We've done a lot of work there. And the good news is, too, is that while this project was about 2 years in length, NC State faculty are continuing to work in Princeville and Lumberton to this day. In fact, they've just finished up some really important work that I'll touch on if I have time. I'll be watching the timekeeper. This is, if you will, for lack of a better term, an organizational chart. Many of these, in fact, if you look at it one way, all of the people on that chart worked with me full-time in the summer last year, it was just a great experience for faculty and students. The College of Design, University of North Carolina Department of City and Regional Planning, which was my former home department. You can see the list of faculty and associated partners, people in North Carolina Emergency Management, FEMA, and others. I'm not going to dwell on it, but just suffice it to say, we've worked with these 6 communities. All of these people were dedicated to working deeply and embedded in these communities for upwards of 2 years. So I want to touch on some of the things that we've done. And when we reached out to these communities, we talked to them and said, what is it that you need that you're not getting from federal and state assistance? And all of the 6 communities had similar responses. Among other things, they asked us to think through how do we design replacement housing for those homes that were destroyed. We did that, and in fact, the College of Design, this is just one rendering of many, and those designs, they're resilient, but they're also given within the range of $70,000 to $90,000, which is a suitable replacement for the homes that were destroyed, and they're actually using these plans to inform the investment of community development block grant funding to rebuild the thousands of homes that were lost after Matthew and now after Hurricane Florence. We also looked at doing what we would call a land suitability analysis, and suffice it to say, it's literally a series of GIS data layers that look at things like, because we were looking at replacing the housing that was lost, but we were also looking at where might we identify land that these people might move to that's outside the floodplain. And the reason that's really important is that a lot of these towns, we were working in towns that had 70 homes in them. 40 of them are slated for buyout and demolition. And if you can imagine, you're losing half of your tax base in a town of 70 people, it's not sustainable. And so not only were we designing replacement housing, but we were looking at areas that might be optimal or better, places outside the floodplain, certain distance to schools, grocery stores, road and water, sewer, and so forth. In a nutshell, that's what that GIS data layer implies. And just very quickly, if you look at the image up here, the green is good. This led to the site selection of replacement for much of Fair Bluff's housing that was lost. So actually we're developing these strategies and they're actually leading to tangible outcomes. One of the other things is the towns, a lot of them are historic, older downtowns located in the floodplain. They're choosing not to leave the floodplain. And so how would you flood-proof or flood retrofit some of these downtowns? And we developed a team of engineers, architects, land use planners, people from State Historic Preservation Office and others. This happens to be Windsor, the town manager of Windsor, and he is just showing us, actually, if you notice the elevated interior floor, that is one basic technique to flood-proof a commercial business. So when the floodwaters rise, the first floor, if you will, is about this height. That's just one of many techniques that we were developing. This is downtown Fair Bluff, and we were looking at, and actually now things have changed because they were flooded even worse in Florence, and so they may actually tear down the entire downtown, which is actually quite troubling because it's a beautiful downtown. It's got great potential. It was already in economic distress before the storm, but nevertheless, this is probably going to be torn down. But the work that we did after Matthew, we were looking at different strategies, including, this is a rendering from a student of mine, is that some of the buildings were substantially damaged. They needed to be torn down. As you may have noticed in the last slide, the buildings are contiguous, but what we were doing is that we were hypothesizing that if this structure is torn down, how can we use this as an amenity? Behind the downtown is the river, is the Lumber River, and so this could be a decent way to gain access to the river. It could be an attractive meeting place and so forth. That's just one of many, many drawings that we provided to these communities that they're using and acting on. Another issue that we dealt with is, we've talked about those that are being bought out and the homes are torn down and that land is turned into open space. But a big question that communities have, especially small towns, they don't have the resources, is what do you do with the land after the homes are torn down? That sounds like a pretty mundane topic, but the small towns don't even have the resources sometimes to mow the grass upon which that vacant land sits. And so we were coming up with all kinds of design strategies, and I'll show you a few examples. This happens to be an image from Windsor on the Kashai River. They turned an area that they were buying out, a lot of these flood-prone homes, into a Frisbee golf course. And actually, so it's a public amenity now in the floodplain, perhaps a more appropriate use. We also looked at, they're exploring issues of educational forest, which of course links us to natural resources. They're looking at things like plant succession. I mean, literally, this could be an educational venue, and that's just one of many, many examples. We were also looking at how you might link these to other state parks, and I'll show you an example of that in just a moment. But also some students were looking at how might you commemorate this land, because try to visualize this concept if any of you have been through this type of event. And I'll get to the example in Princeville, which is very powerful, imagine your home being torn down, you're moving somewhere else, and all the memories that you may have there. So this is just a student's rendering of literally commemorative trees planted, ideally in the space where the home once resided, with a nameplate of the family who once resided there. This is just one example of many that we were looking at, linking design, commemoration, if you will, and alternative uses. The Greenway design issue, the concept of multi-objective management is a big theme we've been expressing or thinking about. So the lands that are being bought out and there's no longer development on them, that can improve your water quality. It can lead to better recreational opportunities. In some cases, development adjacent to those areas, the property values actually increase because you are living next to a green space. All of these things are the type of work that we've been doing. I don't have time to talk about in detail, but nevertheless, just wanted to let you know about some of them. One other thing that's exciting, and this is a tangible outcome of our work, is if you look at the last image or the last bullet, is we've been working with the Cliffs of the New State Park, and what they are going to do is we were developing a blue way. This connects a lot of these communities. For example, we were working in Seven Springs, we were working in Kinston, and many other communities. And so the Cliffs of the New State Park is going to be acquiring the land that is being bought out where flood-prone properties once resided, and they're going to be expanding the state park adjacent to Seven Springs. So again, additional benefits and additional partnerships that are useful. This is an image of Seven Springs, and the image on the upper left is in some ways doesn't seem to be, but it is actually quite troubling. That house is slated for buyout and demolition. There are a number of homes in Seven Springs that look like this that are slated to be torn down. And so we're trying to think through, working with State Historic Preservation and others to save these houses, to move these houses, and we're working on that. And this is actually an image of a lot of the design school faculty working with the town. This is the former town hall. It gives you an indication of the scale of the community. This is one rendering of the 6 for each of the communities. This happens to be Seven Springs. And for those of you that may have been to Seven Springs, this is the high ground. This is where the Methodist Church sits. This is where the town sits, entirely in the floodplain. There was a Civil War battle that was here. The Union forces were on high ground firing into the town and virtually destroyed it. And so there is historic issues. There are, can we think through how we might migrate or move some of these homes to higher ground? What might that look like? This is a rendering of that, again, a student's work. Looking at something as basic as this is, remember, the flood-prone area. This is high ground. This is land that has been purchased by the town of Seven Springs. These are all homes that are slated for buyout and demolition, these here. This is an example of one of the renderings I showed earlier. And so hopefully these designs will lead to the physical movement and relocation of these to higher ground, still in the town limits, so they will still have the tax base, but those homes won't be demolished. So the last story I'll tell, or the last example I'll tell, this is about Princeville. How many have been to the town of Princeville? Any? Couple hands. I would encourage you to take a look, to engage. We are continuing to do that. I should say Andy Fox and others are continuing to do work in Princeville. This is actually a mural that is outside, exposed to the elements. This is one of many panels that commemorates the those that were once slaves moving to the town that is now Princeville. This is Princeville after Hurricane Floyd. Tarboro here on high ground, Princeville is here. This is the levee, it was overtopped. This was in 1999 in Hurricane Floyd. They were flooded again in Matthew. And so they asked us, as one of the 6 communities we've been working with, to do a 5-day design workshop. The other issue that has happened is this workshop helped inform the state has actually purchased this 52-acre parcel of land. This is Princeville. This is all floodplain, all of this in here. This is more recent edge development. This is another parcel that the state is exploring its purchase. They asked us to think through how do we encourage the movement of parts of Princeville to higher ground and what might that look like. So these are some of just the high points of that. We did this workshop. We had 35 architects, land use planners, and others that were engaged. And to me, what was among the most powerful is that Kofi Boone, a faculty member at NC State's College of Design, he purposefully reached out to some of the top African-American designers in the country. And they all came, everyone asked, and they did it for free. They did it for 5 days. And they came, and so when we walked in and introduced the team, it was really, really powerful. Even kids were coming up saying, you know, how do I become an architect? It was one of those moments that just blew me away. And it was a really powerful event. We worked with North Carolina Emergency Management. I'll talk about that very briefly in just a moment. We had in excess of 60 federal, state, and nonprofit agencies that came on board. Of course, we worked very closely with the town. And again, think about this entire area is in the floodplain. This is an area that was, if you will, given to those that were recently emancipated. No people in positions of power wanted to live in these places, but it was their land. It is their land. And so they're deeply tied to this space. And so for us to think about the options of potentially moving parts of the town, many of the people don't want to leave. Many people are contemplating it, and many people are going to elevate in place. So it's a very complex set of issues that we were working with. This is just an image of the proposed site for annexation. This is not the design team, by the way. These are our state emergency managers that played a really important role. Not only did they provide $50,000 to $100,000 in cash, but they also provided, they fed us, they housed us. We could go to the site with drivers anytime we wanted to. We had satellite communications because post-Matthew, the communications were in disarray. They provided all the materials. And even in the upper right-hand corner, we had a check-in every day thinking about documenting our hours. And a lot of the design folks that came in, they didn't want to do that. They thought that was, they want to do the design work. And when we explained to them, we are documenting your time that you're spending about 20 hours a day for 5 days, and many of you are paid a very high rate. We are using that as a non-federal match to help the town. And as soon as they found out about that, then they realized that it was for a greater good. This is Kofi Boone in the middle talking with the town manager, or the county manager, Eric Evans from Edgecombe County, and 2 of the design team. We also videotaped the entire 5-day event. That video is going to be a training video, and that actually is under development. These are just some examples of the students working with the design team. In fact, in the middle, the gentleman, the councilman, this is, for those of you that do know, the Platters. This was the former lead singer of the Platters, is also a commissioner, Commissioner Bullock. In fact, every morning when we got together for meetings, he would break into song. And he would usually sing Only You, and he would serenade us, and it got us pretty inspired. This is just a simple rendering of what that 52-acre site might look like. It is a bit abstract, but it shows the connection to the former town. And what I'm going to do very quickly, if I have just a few minutes, a very small amount of time, is this is the continuation work, very briefly. You can't read the writing, and I know it's too small for you to read, but what's happening is we're doing some very specific things as well. And I should say Andy Fox and Travis Klondike are leading this effort from the College of Design. They're doing tree plantings, they're doing streetscapes, they're doing signage, because they're working on a historic trail that links a lot of these issues throughout town. This is from Lumberton, one of the other towns we're working with. They are looking at how do you link the buyout lands to a larger effort. In this case, it is a connected loop that loops around much of the town that is flood prone, again, turning these flood prone properties into an amenity. The last thing I'll mention very briefly is one of the reasons I was hired is to do a couple things, is to help identify those that are already doing work in resilience on campus. And I will tell you, in 2.5 months, I'm just blown away. I've identified 65 plus faculty members. In fact, it's changing every day that are doing work in resilience, which is unbelievable, and really excited about that. Developing this graduate certificate program with the College of Design, Public Administration, and Engineering. And if you're interested, I'd be happy to talk with you during a break, is I am planning on doing a facilitated fall meeting with faculty that are on campus that are interested in this space. And I'm going to probably draft a straw dog of a strategic plan that would look at how do we take advantage of the unique skills and capabilities that we've got on campus. Sorry for running a bit long, but that's what I have to say. Thanks. Some would say it's a bit of a loaded term. It's a broad term. Sure. In a simple sense, in kind of the common sense, it's responding to an extreme event, a shock to a system, if you will. It has its roots in ecology, actually, but those of us in the hazards field have taken that to look at the idea of more resilient social systems, economic systems, the physical resilience, even environmental resilience, all of those themes. It allows communities to react in a positive way or to rebound or to even think about how you inject risk reduction into the process of responding to a disaster. So in some ways, it's that notion of response or rebounding from an extreme event. Yeah. But it spans many domains. So, yeah.
Your product of this, are you going to develop a manual or something that places can use to say, do this, you have this condition, so you can just build model.
Well, that's a great question. I would like to. So we've got on a smaller scale, we've got the work that we're doing with the video for the design workshop in Princeville. I would like to do that, and I should have mentioned, this is really the first node in a larger network. In fact, it's tied to an international learning lab that we're developing, and the US node is actually going to be North Carolina. But yes, would be interested in developing a guide as to how to do this, how state agencies might support this, because this is a real problem in the field, is that communities are often overwhelmed and they don't get the assistance that they need. The needs aren't necessarily reflected in the aid that comes in from external entities.
I honestly thrown away, but equipment. If you do that, one of the things that always is that people have the community leaders have a good idea of the cost, aspirations of cost.
Right. Okay. Fair enough. Yeah, we can talk at break. Okay.
So our next speaker is Vida Misra. She is a professor in the Department of Electrical Engineering and the director of the ASSIST Center. And I have to cheat because I can never remember the acronym, but the Center for the Advanced Self-Powered Systems of Integrated Sensors and Technologies.
Thank you. We have 16 minutes. All right, well, it's a great pleasure to be here today and talk to you a little bit about what our center is doing that's across disciplines, and also identify maybe some new opportunities for multidisciplinary work that maybe some of you are interested in. ASSIST is funded by NSF. It's an ERC center. We are in our 7th year, and we are currently buried in reporting requirements that are due next week. All right, let me jump into it. For those of you who have not seen ASSIST's vision and goal before, we are really going after healthcare. As you may know, healthcare costs are a huge amount right now in the US, 17% of our GDP. Much of this is connected to chronic diseases, and Americans, typically as they age, have multiple chronic diseases. Another facet that's very interesting is the air quality, which we don't know that much about, but there is a connection between air quality and health. In asthma, it's obvious, but in other areas, there's also some growing evidence that air quality can affect cognition and cardiovascular disease. So with all of this expenditure by the US government on healthcare, the outcomes are actually not so good. Some of the latest data from the last couple of years actually shows that the life expectancy is going the other way in the US, and it's doing a downturn. And so this is really a problem. And so what do we do to get out of this trap? And there are lots of think tanks and lots of advisory boards, but in general it boils down to we need better personalized health. We need to be able to get better at population health, predicting population health, and we also need to use digital technology and go with the concept of digital biomarkers that can help us explain and influence and even predict health outcomes for individuals. At the end of the day, we want all of this information to help us gain fundamental insight into how disease progresses. So let me walk you through what the major challenge is that we are trying to provide solutions for. So the current medicine, for the most part, this is not true in every discipline, for the most part, you have one general treatment that is applied to different populations, and you expect that the therapy on the left will work for everybody in your group. But that usually does not happen. Some of the members definitely have an improvement, but others either don't have any improvement or they actually get adverse effects. What we need is more personalized medicine, where you can individualize and customize treatment plans for different populations, different demographics, and then you can expect to get much better outcomes. So the way we get here is really by individual monitoring over long periods of time. And if we can enable people, individuals, and give them technologies that they can use to monitor their own health, not just for a couple of days or a couple of months, but long term, then we can really start building a database of health for that particular individual. And also, this will identify trends within population health, so we can see these subgroups within the population subset that will allow us to do much better population health. So in other words, individualizing monitoring of different health parameters not only helps the individual, but it also helps the population. So that is really the goal that we embarked on about 7 years ago. Our vision in the center is to build disruptive systems using research breakthroughs that create self-powered sensing, computing, and communication systems that can enable data-driven insights for a smart and healthy world. Our systems are unique because while you may already be wearing a wearable right now, our systems are self-powered. They don't need a battery. They work off of human body power. They have multiple sensors on them, not just your activity monitoring, but your physiological monitoring, environmental exposures, such as what are you getting exposed to when you go to a particular building, and even biochemical sensors. How is your lactate level or your other, some kind of a hormone level changing during your daily activities. These systems are wearable, wireless, and comfortable, and really the end of the day, it's the power that's coming out of this system is the data and what we do with the data. So our systems center is very top-down driven. So we are not a center where research technologies are just being developed for the sake of being very fantastic. We are really going after big problems. And so we have assembled a team of medical advisors and partners, and they have identified sort of these 5 use cases that have either a large number of people in the world being impacted by them, or they are very costly. And we have owned these use cases, and we're developing technologies to understand the solutions in this space. So for any of you electrical engineers in the audience, are any of you EEs in the audience? I don't see anybody. Oh yes, hello. Hi, John. So this is our block diagram, and basically this block diagram may look very generic to you if you've seen these kinds of things before, but everything in green that you see here is something that Assist Center is developing in a disruptive way, whether it's supercapacitors to hold the energy that can outlast batteries, whether it's energy harvesters that can harvest power from the body, either using body heat or body motion, whether it's the actual chip that does the computing or the radios that send the signal out, all of the green blocks are being developed within the Assist Center. So, and then the data from the wearable node here on the left side is being sent to a smartphone or any other kind of device that you would like, and then there it's processed and sent to the cloud and so forth. So on the right side is pretty much a standard infrastructure that we plug into. The left side are all the disruptive technologies that we're developing. So I don't want to give all the details. I don't even have time to give all the details, but these are the general areas in which our technologies are coming into play. We are developing cutting-edge technologies, energy harvesting, in low-power circuits and radios, in non-invasive biochemical sensing, either using sweat or with some kind of minimal invasion with the needles, microneedles, using interstitial fluid. We are looking at materials, whether they're flexible polymers, stretchable polymers, or textiles, and then we are growing our effort on data in the last year or so. So here is an example of the different kinds of things that we have built using energy harvesting technologies. So whether it's a wrist device that you simply wear on your wrist and you walk around very normally, and it can gather power on the orders of hundreds of microwatts and dump it into a storage device like a supercapacitor. Or whether it's a heat harvester device using thermoelectrics. Or even if you're sitting in a room like this and there's Wi-Fi in the room or some kind of energy available in this room, we can harvest that as well using garments and integrating antennas inside garments. So here are some very exciting, very recent results. This is a thermoelectric wrist, almost wrist band, but much wider. And it's placed on this student's arm. And you can see that when this person goes outside, the temperature difference between the student's arm and the air outside is a healthy amount, and it can generate over 1 milliwatt of power. 1 milliwatt of power is a huge amount of power for the kinds of systems that Assist is building. So with that kind of power, we can power up a variety of different sensors. But even indoors, where the person is not doing anything, there's still quite a bit of power that we can generate. So this is an example of the kind of work that we're doing with energy harvesting. In our ultra-low power chips as well, we are developing disruptive consumption, very, very low power consumption. And this work actually is being done at UVA, but we often collaborate with our circuit designers here on campus for new directions. But I won't go into too much of that here. Here is a work with our chemical engineering colleagues at NC State, where we have developed a microneedle patch here that goes under the skin to collect interstitial fluid. This fluid can then be evaluated for glucose or lactate or other kinds of biomarkers. We also have a sweat collection platform, and these platforms work together. Sweat is being collected for lactate, and interstitial fluid is being collected for glucose. And then the data is being analyzed. All right, and in flexible materials, we have a lot of exciting work going on. Of course, we have a huge presence at NC State in textiles, so we're taking advantage of that. So textiles integration, carbon nanotube heat sinks that are flexible and also have very high thermal conductivity, so it can be placed on top of thermoelectric devices to push the heat out. Microneedle, small microneedle patches here that you can see. And then on here are some detailed images of textiles fibers that we have used to functionalize some of the sensor work. So with all of this research technology, our goal really is to go back to those use cases that I talked about, those health use cases. And so with our research technologies on the left, we integrate these in a variety of different formats, different form factors, different locations on the body to be able to address these use cases, like I said, asthma, vigilant atrial fibrillation, diabetes, actually specifically diet management for pre-diabetic individuals, and wound monitoring. So over the past several years, Assist has been busy in integrating all of these different kinds of technologies into systems that are doing something useful related to those use cases that I mentioned. So here is a flexible energy harvester device. Here is a chest patch that monitors ECG signals continuously. Here are some some electrodes that have been embroidered onto fabric for wound monitoring of uric acid. Here is our very cool battery-free garment shirt that can measure ECG without the need for any batteries, but it's really provides vigilant monitoring. Here is our asthma monitoring watch that measures environmental toxins. Here is our, the watch has been designed in such a way that you can swap in and out different sensor boards. So whether you have a sensor board for an optical sensor for, let's say, heart rate, or you have a board for volatile organic compound sensing. So we have really worked hard to get from where we were in the very beginning, which was just a box of sensor, to this kind of platform that can allow you to plug and play different kinds of sensing modalities. And then here is our energy harvester of Wi-Fi that can generate 1 milliwatt of power just sitting around. So these are the different kinds of systems. I think in interest of time, I'll skip some of these slides and maybe talk more about the cross-disciplinary aspect of our research. So with our systems, especially our asthma monitoring systems, which are the most mature right now, we are working actively with clinicians at UNC. We have 9 IRB protocols that are being conducted, and we are testing these out in the clinical setting. The data that's coming out of these devices is being analyzed, algorithms are being developed, and most excitingly, we are publishing papers that have computer scientists, a pulmonologist, and electrical engineers working together. So this is, I think, some of the real outcomes and new learning that can happen when these different communities come together. Here is our ECG shirt, the one that doesn't need a battery. Here is Braden from Textiles, who's wearing this shirt, all developed here at NC State. And in this particular demo, the ECG signal looks noisy, but believe me, it looks very clean when we demoed it at the industry meeting a few months ago. But these are the various kinds of platforms that our textiles engineering colleagues are building that incorporate different sensing modalities and energy harvesting modalities as well. Let me move on, and I'll go on to, and this is just examples of the different systems we have built for a variety of use cases. I want to say a little bit about our industry program. Along with NSF supporting us, we also have industry members supporting us as in a membership scenario. And if you know any of these companies, you sort of know all the different disciplines that they come from, and they help us fill gaps and actually sponsor more of our research. We have been, because we are in this broad space, we have been inventing and commercializing some of our work. You can see some of the metrics there, but we are very pleased with the level of commercialization that we have been doing and the opportunities that are coming up. An ERC center also has a big education component, and so one aspect of that is an undergraduate minor that we have created in our program, and you can see that so far with 42 undergraduates data that we have, you can see all the different departments that are involved in our undergraduate minor. And not all of them are engineering. We have international studies, we have polymer chemistry, and medicine as well that's captured in a small sliver. And Greg specifically asked me to talk about perhaps some new directions that could involve different areas. And I was just put some thoughts together. I think, and these are mostly in health, but others as well. So in the area of brain sciences, maybe some of you are working in the brain sciences area, there is a lot of opportunity to use different kinds of technologies to understand brain stimulation, provided you can make these things wearable, non-invasive, even provide wireless stimulation and dynamically steer the stimulation beam. Lots of applications are there, for example, memory, understanding memory loss, Alzheimer's, drug abuse, epilepsy, and so on and so forth. And in this regard, I think this kind of field requires some advanced transducer design that can provide stimulation and manipulate it, that's integrated with electronics, smart packaging, and of course, low power operation. Pain monitoring is another huge area, especially with opioid abuse, and I think doctors really would like a way to monitor the patient's pain in an objective way, which is very difficult to do, but there are people working on this, and technology, sensing technology, especially bringing many different sensor modalities together and doing artificial intelligence, machine learning, you can understand perhaps some predictor of pain or some metric of pain. So what we need is a multi-sensor platform that's connected to pain, and we need continuous monitoring. So again, a lot of the, in our case, assist-like technologies play a role here. In implantables, there's also lots of opportunity, provided you can overcome the biggest barrier of implantables, which is energy requirements. You don't want to take out the device to change the battery. which is the case for pacemakers. So if you could provide energy wirelessly in an efficient way, especially for deeply implanted devices, that would be a huge breakthrough. And so that's definitely a research need, and biocompatibility with packaging materials is also a huge opportunity. And here are some things that we have worked on together with Profusa. Their implanted device is sitting under the skin. We have built devices that can receive the signal from under the skin. I'm out of time, so I wanted to just mention that, let me go here a little bit. In smart cities and smart homes, there's also opportunity for cross-disciplinary research. We feel that with our self-powered nodes, we can expand to IoT, monitor environmental exposures in buildings or in cities, but it also needs flexible materials, lots of data analysis, and security. So this is another growing area with lots of funding in the horizon. Plants, you may have heard about the Plant Sciences Initiative. I believe people are here from the Plant Sciences Initiative. And this is an area where some of the technologies NC State is developing are doing quite well, whether it's gas sensing or energy harvesting, lightweight, flexible materials. Data is another piece of this, and that's there. And then finally, animal health, that's another interesting area. Animals can't talk, so whatever we can do to sense what they're going through would be very enabling. And so I've listed the research requirements there. So I'll skip this. I wanted to show you this one interesting slide. This is our ASSIST team when we first started and where we are now. And I see a plot similar to this on a poster on this side. And the idea is, how are we capturing our interactions and our success of working together? So back when ASSIST was first established, 2012, we had these nodes of our PIs that are all over different disciplines and different universities. And as we grew into a center, we started building these nodes. You can see the lines, hopefully, and these lines are right now capturing only the publications, but you could build a similar chart capturing proposals submitted. And this is next year, the next year, and next year, and then I think this is the most recent one, which is still 2 years ago, showing all the different dense networks that we have created within the program. All right, so I've taken up my time. I'll just leave this slide up and happy to take a question or two, if there's time.
Your first slide showed, the issue in the U.S. of age and death going down.
Yeah.
And that this is sort of a response to that. And I'm just trying to think in terms of, do you have economists and social scientists involved in this in terms of determining which of these kinds of innovations could actually change that curve more than others in terms of where you invest in that?
Yeah, and that's a great suggestion. We don't have economists involved in our team right now, but in looking at some of the studies that have been published, majority of the chronic disease costs are connected to a few factors. One of them is excessive testing in the hospital, and this kind of technology could really help with that. And another one is readmissions into hospitals. So when somebody is released, they get readmitted, and that's a huge cost. So again, something like this would help monitor the patient once they are released. But I think there is a huge opportunity for economists and others to get involved and see what the real impact of this would be and what else we could do differently to lower the cost.
I just have one question about the life expectancy in the U.S. It's lower than other countries. Is that really, with that, is to evaluate all, I guess, is it?
That is not my plot.
Doing academic.
Oh, I don't know.
We have entire, towns in, let's say, Ohio that are 90% is high risk. Yeah.
I was just sitting there and I got a text saying that the opioid deaths are up by 1,000%
Yes.
just now.
Since last year.
Yeah. Yeah, so that's a good point. I don't know exactly what has made the curve go down so dramatically in the last, it's already lower. It has been lower than other countries, but there's a very dramatic curve, down curve, but I'll find out. Yeah. Here, thank you.
So our next speaker is Ralph Dean. He is a professor in the Department of Plant Pathology in the College of Agriculture and Life Sciences.
questions? Or at the end? Okay, well, good afternoon, everybody. I'm going to sort of slightly take a little bit of a different tack in the sense that one of the principal purposes of us gathering here today is to figure out how we can actually establish new partnerships. And I've been involved in a number of these type of different events, so I'm going to sort of give you a little bit sort of background of what I'm kind of interested in, and then how I have come to establish different types of partnerships with different faculty members across different colleges. It's great that we have all these activities that are really well developed, and these are highly successful collaborations. But the question is how do we continue to build those and develop those? And so I'm going to talk about sort of examples from my own personal perspective on how we have been able to do that in a smaller way, which will be leading to larger types of things. So what I'm going to be talking about in general is going to be about electronics, the use of electronics, and plants. But I'm going to digress a little bit to begin with, because basically it's all about communication, not just in terms of what I'm interested in, but what we're all interested in terms of how do we establish new partnerships, and it's through different types of interactions and how we figure out how to facilitate these type of interactions to make things work. We can't always jump in at the deep end, so to speak. So I'm going to talk about communication as it relates to plants, specifically how plants can protect themselves from pests and pathogens. And there are various types of signaling systems, communication pathways that are involved in that. And I'm going to sort of walk you through a little bit of my background, how I got to where I am now. And the question is that there are these signaling systems. Plants don't talk, but they have a language. So how can we eavesdrop or extract this type of information about how plants are communicating, and how can we use that information for, in this instance, to improve agricultural productivity? And as you'll see, that this sort of highlights the need to court these different types of interactions between different groups of expertise, whether it be me with plant background or other people, be engineers or with chemists who have different skill sets that we can bring together, come together in different scales to be able to develop solutions to some of these underlying questions. Okay, so I'm going to go back to early days, for me anyway. So I was amazed when I was a student. I discovered that plants, like animals, have basically an inducible defense system. And this was quite revolutionary to me at the time. I mean, this is quite a while ago. And now we refer to this as acquired systemic resistance. And this is actually a diagram from some of my own work from years ago. But basically, what we're seeing here is that on the right-hand side of the plant, there's an induction, there's a small stimulus that results as we move around clockwise to the release of these systemic signals, which then can activate the plant so that the plant now becomes eventually protected from subsequent infection. So it's all about these mobile chemical signals that are moving throughout plants. And interestingly enough, the compounds that we helped discover involved in this are sort of related to aspirin. It's not actually aspirin, it's salicylic acid and some other derivatives. And these have subsequently gone on with work that we did and others have done with a number of the ag biotech companies, have led to commercial products. And one of the most well-known is something called Actigard. So this is a chemical that it's not a fungicide, it activates the plant's own defense mechanisms. Amazing. Anyway, so from there, I moved on to work on another signaling system, and I worked on something called cyclic AMP. And this is a derivative of ATP, and cyclic AMP is one of the central signaling molecules in life. Not just in plants, in life. It's a second messenger. It relays communication from one sort of biochemical pathway to another and amplifies that. I mean, I don't really have a good analogy, but it's like the baton. The baton, to win the race, you have to get the baton around in a relay race. And it's the same kind of thing with these signaling molecules, these second messengers, is they have to relay this information across systems. And so we discovered quite some time ago, more than 20 years ago now, that this system is crucial to developing defense pathways in plants. And the way that this works is that it's a phosphorylation relay. So proteins get phosphorylated. As they become phosphorylated, they become active. So yeah, we all think about genes as being the critical element in our bodies. They are, because they encode the proteins. But the activity, the actions that occur within our cells is due to changes in those proteins. And one of the critical changes is through phosphorylation. So this has led to this field of what we now think of as phosphoproteomics. And I know that Dave Muddyman is here in the back row. I see him sitting there. So it just happened that I was in a seminar for another student in my own department, and who Dave was actually working with, and suddenly mentioned that they have this expertise to do this. And all of a sudden, this sort of opened my eyes to the opportunities that we have to actually develop this new technology to understand plant defense mechanisms. And so I've worked with Dave for more than 10 years, and it's been a really interesting and successful partnerships. We've got more than 12 publications. There's more coming over the period of 10 years, and it resulted in fabulous funding opportunities. We were funded by the NSF, competitive grants from USDA. So again, this is an example of how that, just through a happenstance and the curiosity that one has, to explore these type of partnerships. So that brings me to now. In 2016, I took a sabbatical. And on that sabbatical, I worked on stuff completely unrelated to what I normally work on. But I really encourage everybody to think about a sabbatical, because it's the time you get to think about what it is you're interested in. And I've always been interested in communication. And so when I came back from my sabbatical, there was a workshop similar to this in many respects, that was organized by CALS and the College of Engineering. I think people like Becky Boston and Alan Rebar, and I forget a bunch of others, Michael Steer, John Gilligan, and a few others. And what we did, we had, and I'm sure a number of you have probably been involved in these things, are these quad charts. It's a single slide where you make a pitch. And it was, so we basically, I think it's probably going to be like this session that's coming up. So it's like you get like a minute to make your pitch. And it was remarkable that at this event, which I had no great aspirations of, I was energized, I was back from a sabbatical, I was ready to take on the world. And it was amazing. At this particular workshop, the number of opportunities that seem to exist between the plant scientists and engineers to work on sensor-related technologies. And I thought, wow, this is incredible. Why didn't I know this before? So it was a real eye-opener, was this type of opportunity. And I've listed a few things that came out of that. So there's developing sensors for volatile organic compounds, and I'm going to talk about that, but there was others of sort of on-plant sensors using nanocellulose, or measuring changes in metabolism through drone technology and other stuff. But it was remarkable that there was this underlying commonality across our two colleges that it took me, I've been here for 20 years, to figure out that there was this common area that we could work together on. Anyway, so that really changed my outlook. And so let me tell you a little bit about plant volatiles. So we all know plants can smell nice. We all know that plants can not smell so nice. We all can detect a moldy basement, okay? So it's clearly that volatiles are playing a very big role in everything related to plants and microbes and other things that are going on in the environment. And we know a lot about the pathways. These pathways, these core metabolic pathways, I mean, you can see some of them here. I mean, there's things like isoprenes and phenylpropanoids and other stuff that's on here. You've got, I can't read this very well, but sesquiterpenoids and hemiterpenoids, and you've got jasminates, And then you see up there the green on the top right, the green leaf volatiles up here somewhere. Again, we all can smell, we all know when someone's cut the grass, right? Because they're releasing all these volatiles into the air. Why do plants do this? Good question. They are screaming. They are indeed screaming. And mainly they're screaming for help. Okay? And so I sort of, here are some of the different things that go on when plants are releasing these volatiles. Plants are doing it for a variety of reasons. They can warn other plants of impending danger, so that the neighboring plants can activate their own defense mechanism. They can attract pollinators, they can attract animals to disperse seeds, they can attract predators that can come in and attack herbivores. So there's a lot of different things that all these volatiles are doing. They can activate defenses, attract beneficial insects, warn adjacent plants. An amazing world of the plant volatiles. We can think of this as plant talk. How the plants are communicating, they have their own specific language. And this language is composed of more than 1,000, potentially 2,000 different volatile compounds that are released from plants, okay? Not every plant produces every one, and I showed you the main pathways, but it's those tips, it's the leaves, okay? And that's where the specificity comes in. And indeed, it's the composition of these particular volatile profile, okay, that is a sort of a diagnostic signature of what's happening in a plant. So how can we detect and exploit this? And so this is where these informal discussion leads to this partnership. And this partnership, there's myself, Sophia Carthuriou from food, bioprocessing and nutrition. She's interested in foodborne illness and how can we detect foodborne pathogens. Greg, who did the introductions, interested in how can we modify materials as detectors in life sciences. And critical to this is Omar Oralkhan, whose name you saw on the previous slide. So we had this great idea about developing these sensors, and we said, well, how can we get this off the ground? So we put together a small proposal. We took it around our different departments, our different colleges, and boom, we found someone who was willing to bite. And this was the North Carolina Agriculture and Life Sciences Research Foundation. Their purpose is to raise money, not to spend money, it's to raise money. But we made a good pitch to them. And we were able to show that we could gather additional resources from our home departments to put together and leverage and make a package. And they bought it, they bought in. So the foundation of this is this technology. And it was introduced a moment ago, is this particular type of sensor. So it's a gas-based sensor, and as we heard, it can have different channels, so the channels can be switched out. And it's low power in this instance. It's driven from a watch battery. It's about the size of a quarter. It's wireless, it's low power, et cetera, et cetera. And this was, as we heard, is developed as a wearable device. So the question, so how does this thing work? Well, basically you can think of this thing as the little micro drum. So on the left, you see this little symbol there, and what happens is if you put a functionalized layer on this, and you change the properties of that layer, it will bind different molecules, okay? So when molecules bind, it changes the resonance frequency. It's a little micro drum, and so the resonance frequency changes. As you can see there in the middle panel, when molecules interact, changes the frequency, okay? When you remove the molecules, it goes back to baseline. So what we can do, and this is what we're working on, is you can modify the different functional properties, okay, of these different surfaces. So you can see that in this example, we have 6 different functionalized layers, and you can see that they will respond to different volatiles in a differential way. So essentially, you get a unique fingerprint. So that's the idea, to do this. So does it work? Can we do it for plants? Can we use it for plants? Well, this is our first experiment, and bingo, a huge response. So in this, you see this corn plant inside this glass dome with a sensor inside of it, and we wound the plant. And you can see that essentially immediately upon wounding the plant, there's a huge release of volatiles and we can detect them. Fantastic. So we've gone on, now we've built multi-sensor arrays. So we're trying to develop different sensors that have different sensitivities, different properties. And we can see here that upon wounding, again, we see differential responses. We haven't yet demonstrated that we can actually distinguish the different types of molecules, but that's where we're going with this. Not only plants give off volatiles, fungi, the moldy basement. This is really important because many fungal pathogens produce a variety of noxious compounds, and many of them are volatile. So here's an example where we don't necessarily have to detect the disease. We can detect that signature of the infection. Okay, we need to identify what the compounds are, so we do the standard approach. We can see some nice red peaks here. So these are different compounds that are released during that few minutes, different than we see in a later time. Okay, so we can check these, so that's what we're doing. When we have the presence of a particular volatile, the sensor goes off, etc. So we're now distilling down, figuring out what these different volatiles do. The other important thing about this was that we wanted to generate some real excitement about the possibilities of using these type of technologies. So myself, in collaboration with Omar, we approached our college, the College of Agriculture and Life Sciences, and in collaboration with the College of Engineering, we co-organized and hosted a major conference, and this is part of the Stewards of the Future conference. And this took quite some effort to make this happen last fall, but the Stewards of the Future series is one of the flagship symposia that the College of Agriculture operates. And this was really a very impressive event. We were able to generate a lot of resources to come into this to support this particular thing, this particular activity. We had worldwide speakers and we had worldwide participation. We had 150 people paid good money to come to this thing. So it really enabled us to get this whole activity to the next level. So let me just conclude. In a short period of time, through perseverance and having, I think, what was a really good idea, we've got a productive and a visible partnership between faculty and our two colleges. We're developing the technology. This technology was developed here at NC State, which is absolutely wonderful. There are endless opportunities and applications for this type of technology for basically sniffing out, sensing different volatile compounds. We've been successful in getting corporate sponsorship. We have a major sponsor and recently got an NIH postdoctoral award to support this, so it's all moving in the right direction. And I should say that this is just part of a much larger initiative ongoing here at this university. There are other fruitful collaborations between members of CALS and engineering. And Kranos Williams, I know he's here today. I think he's going to be presenting or discussing some things about some other global opportunities for partnerships relate to this initiative. So overall, in a very short period of time, the future looks very bright. All right, that's all I have to say. Thank you.
And if you wouldn't mind repeating so that the folks listening online would be able to hear the question in addition to your answer, that would be great.
Okay. Yeah.
What are the VOCs doing when you wound the plant? I mean, are they doing something to help the plant heal?
So the question is, what are these volatiles doing when we wound a plant? So you're releasing a lot of terpenoids and green leafy volatiles, which typically we can smell. But it's very interesting that they're actually warning neighboring plants. They're warning a neighboring plant that we're potentially under attack from a herbivore. Activate your defense mechanisms. So there's well-established literature on this that these volatiles can travel many meters and they can activate some of the classical jasmonate and salicylic acid pathways in plants so the plants can be ready. And it all ties back to some of my original work on systemic acquired resistance. It's the same general idea that these are mobile chemical signals that are involved in activating plant defense mechanisms. You're welcome.
Okay, so we are about to get started on our first round of lightning talks. So this is going to be quick. Everyone's going to have 2 minutes, and I think Laura has a very efficient get them mic'd up, get them walking across the stage, but hopefully then this will set up the opportunity for additional discussion around the posters and at the break, which will happen immediately following these talks.
I do need to ask if anybody is a part of the first lightning round session and has not already met me over there, please do. I am missing my first speaker, if Marshall Baker is here. Ah, okay. We'll start. Why don't you go up to the middle and I'll start your clock for you.
Thanks. I got so engulfed in the science, I forgot I was supposed to go meet at the door at 2 o'clock. My name is Marshall Baker. I'm an assistant professor here in the Department of Agricultural and Human Sciences. And so my science is I'm a social scientist in the College of Ag and Life Sciences. And so a lot of times that brings an interesting perspective. What I'm looking to do is to help translate your science, a lot of your science, translate that to communities, to families, and to youth that will be consumers of that science. And so we do understand with cognitive psychology how people perceive science, and that's a big challenge. A lot of the research looking at rural receptivity of science and how we can work to improve that. Specifically, I study the cognitive psychology of how people learn, grow, and behave. And that is grounded in experiential learning theory, which talks about the fact that all of us have sensory experiences, the environment that we live in, and then how do we make sense of those experiences and come to conclusions and beliefs that then will drive our behaviors. And so often in the College of Ag, we see a lot of science that is being produced, but I like to look at how will, I start with youth because they're the best mechanism for me to produce change. How can we prepare a society to accept and understand and be scientifically literate to consume and interact with your science? And so my primary mechanism, the specific problem that I address, is we have high school agri-science students throughout the entire state. And so that gives us a phenomenal mechanism to help impact every single community and tens of thousands of youth that will be directly involved with many of these sciences. So my outcomes are looking to recruit those people to science and to help them ultimately become scientific, literate citizens. So I'd love to collaborate for any of you that have scientific, some of your science, if you need some help moving that towards education or outreach or the human dimension, I'd love to work with you.
Good afternoon, everyone. My name is Jade Berry James. I'm an associate professor in the Department of Public Administration on campus here. I'm in the School of Public and International Affairs. And so one of my research interests, well, my primary research interest is really around social equity. I like to say that I practice in creating usable knowledge, looking at policies, programs, and practices that really promote fairness and justice in our field and in our society. I'm a program evaluator, and I have an expertise in assessment and accreditation. I've been doing that work for about 32 years in higher education now. And so most of the programs that I've evaluated are federally funded initiatives that look at food equity, alternative education, substance abuse treatment programs, juvenile justice programs, and emergency management programs. I have a current book that was recently published this year. It's called Why Research Methods Matter, Essential decision-making skills. And what it really does is it really showcases the power of program evaluation to really look at the kind of knowledge that we're really trying to use to make good decisions in our field and in every field, quite frankly. So my presentation, my poster presentation today is really about responsible innovation, and it's looking at inclusion strategies in cultural perspectives around genetically modified foods. And so I'm at poster number 2. It's over by the exit door. I hope you'll stop in and see me and say hello at the very least. That research study was really supported by the Genetic Engineering and Society Center here on campus. I believe they're located in the fifth floor of this particular building. And then I'm looking for research collaborations in really 2 areas. One is in public engagement strategies in science and technology. I love to do evaluation work, which includes needs assessments, as well as connect research to communities, underserved communities in particular. And then the other thing is really focused on building trust in diverse communities. I love to focus on the town and gown approach. I really believe that the kind of things that really make us valuable at NC State is our ability to go out and make the world better. Thank you very much. Appreciate my 2 minutes of your time.
Hi, everybody. Philip Bradford. I'm an associate professor in textile engineering program, and my background is in textile engineering and in material science. And so my research kind of combines these 2 areas in the field of textile nanomaterials. I am an expert in growth of a material called carbon nanotubes, which probably some of you have heard of before, but essentially extremely small diameter fibers. In this field, traditionally, these fibers are microns in length, so when you buy them, they look like a bag of black powder. But my group is focused on producing these materials at a much larger scale in terms of their length scale in order of millimeters. And when we do that, we can translate these into things that look like yarns and things that look like non-woven textile materials. And so they have a lot more useful functionalities than just taking this black powder and mixing it in something else. And so my group has studied these textile-like materials made of carbon, and they have very unique properties: high surface area, high electrical conductivity, high thermal conductivity. And so we've used them for textile-like applications such as filtration, but we're also interested in advanced areas such as energy storage and catalysis and other things. And so there's a lot of opportunity for collaboration using this kind of very novel material as a source of collaboration between different people that are interested in new materials for their particular applications. So my poster is number 4, right as you walk in through the door, so I'd be glad to talk with you all if you have some ideas about collaboration. Thank you.
George Elvin from the School of Architecture, and like Gavin, I work with hurricanes like Florence, which just last year killed 39 people and did over $17 billion in damage just in North Carolina, one state, one storm. And part of the reason for so much damage is, as Gavin talked about, where we build, also how we build is critical in that, and building resilience and resistance to hurricanes. And so the light wood framing system that we use for single-family homes, for example, is efficient and affordable, but not when it goes up against a hurricane. And so we are looking at resilient framing systems for residential buildings and residential scale buildings for the coasts and throughout the state, ultimately throughout the world, since these kind of events are happening with increasing severity and frequency all over. And adapting that lightwood frame system and incorporating new systems, some of them going quite traditional, like pole framing that has been around for a very long time, but then also weaving in new technologies like laminated veneer lumber, which hasn't been around very long at all, basically making our buildings stronger and more hurricane resistant moving ahead. So designing this system, building it, testing it at the constructed facilities lab, hopefully within the next year, and then ultimately implementing that. So we're poster number 5 over here. Look forward to talking to you.
Hey everyone, my name is Nathan Crook, and I'll tell you a little bit about what my lab does. We engineer gut fungi for drug delivery to the gut. I want to emphasize that that fungi are a resident of the human gut, and there are in fact probiotics that are fungal in nature, in particular Saccharomyces boulardii, which is interesting because it is a close relative of baker's yeast, and so is engineerable just like baker's yeast is. What we do in our lab is note that very little is known about the roles that fungi play, and use that as an opportunity to engineer them for controlled phenotypes like drug delivery. The reason why fungi are a useful platform is that they can secrete post-translationally modified proteins, which are a major class of biologic drugs. These are very easy to engineer, and we can potentially use them to modulate the growth of bacteria without impacting their own growth. We can also think that they might have some containment advantages relative to horizontal gene transfer in the gut. But what my lab does is focus on this probiotic yeast, Saccharomyces boulardii. We've developed a colonization strategy so we can colonize this microbe in mice. We can control its gene expression very precisely so we can dose this drug as we would like. And we're looking for collaborators in particular in disease models. So we'd like, if anyone is developing drugs against in particular gut disease, we can deliver these drugs in a new way. We can also potentially deliver modulators of this disease to test hypotheses about what these diseases are doing. So if anyone's interested, I'd be happy to talk to you. I'm in poster number 6. Thank you.
Good afternoon. I am Kwesi Brookins. I am Associate Professor of Applied Social Community Psychology as well as Africana Studies. I am presenting on behalf of our partnership that we have between the Vice Provost's Office of University Outreach and Engagement, Wake County Cooperative Extension, and Wake County Social and Economic Vitality. As we all know, NC State is a land-grant university. What we don't often think about, however, is the fact that we are also an anchor institution that has a tremendous amount of economic, social, cultural, and economic impact on our local and regional communities. The Office of University Outreach and Engagement seeks to promote, connect, and support faculty, researchers, and students in ways that the university can more intentionally partner with our local communities to have broader impacts on community-identified needs. The Wake Community University Partnership arose out of 3 strategic goals: build a culture of engagement, enhance our community collaboration and partnerships, and develop our capacity to make a difference. The route to accomplish this is built into our framework of faculty responsibilities and the scholarship of engagement, which provides a pathway for transdisciplinary research and scholarship, as indicated in the graphic on the, is that your right or left? Can't remember, okay. This year, NC State signed a MOU with Wake County called the Wake Community University Partnership. The goals of the Wake Cup are to find ways to leverage the intellectual and research capacity of the university to collaborate and partner with organizations in 2 engagement zones, Northeast Wake and Southeast Raleigh. We believe these focal areas that you see here provide opportunities for collaboration by transdisciplinary scholars across the university. And I am over at, what is this, number 9, I think? Poster number 9, and it's right, you can't escape the room without passing by me. So if you do not stop and have a conversation with me about how we can partner, I will not be happy. Thank you.
That's apparently me. I'm Sharon Lupkin. I'm in the Department of Mathematics. I am an applied mathematician, meaning I'm applying the math to real problems, primarily in biology, but not exclusively. I primarily am looking at problems in developmental biology, but also regenerative medicine would be a reasonable area of application. I tend to look at the tissue level. Cellular level happens sometimes, and the tools that my group applies are partial differential equations for mechanics and transport. We're tracking the components of the system by building not a model. There's a misconception of what modeling does, that the task is building the model of the biological system, but a much better way to approach it is to think of creating a set of models and comparing how different assumptions will lead to different insights. So a typical workflow, which I've got on my poster there, has a biological question. So here's a lung question. Why does closing off the trachea increase the level of branching? Not what are the molecules, but mechanically what is going on, physically what's going on. The initial hypothesis from the people who did that lab work was that the tissue gets stretched and that leads to more branching. So we throw a couple of models with very carefully stated assumptions at that and look at where the stretches would be. It didn't seem to fit what was known about the system, and that insight that the first order model didn't seem to work leads to the next model. The next model in this case was, well, there's some transport involved. What is being transported? Would that have anything to do with the biological question? So you can get further details at my poster, but the idea is collaborating on clarifying ideas which sound good when you think about them or sound good when you articulate them, but when you specify them quantitatively, that can be a lot harder to justify. That's my work.
All right, good afternoon. My name is Thomas Chase. I'm a research scholar at ITRI. Our institute was established in 1978. We are under the Office of Research. We are fully grant funded and with no appropriations. We have about 50 staff and around 60 to 80 students, depending on the year and how busy our summer is, that work with us. My background's in civil engineering, and I'm going to talk with you today about our Connected Autonomous Vehicle program, which I lead at ITRI. I also lead our ITS and Signals program as well. ITRI is itself fairly multidisciplinary, but we're always looking for new collaboration opportunities. We have folks that work in design, planning, marketing, economics, and other areas. And when we look at connected autonomous vehicles, we're really interested in the holistic picture of how these systems operate. And in this case, we see both connected and autonomous as separate and combined technologies, and so we're interested in each of those aspects individually and together. I've got a slide with some pictures and then a slide with some words, so we'll switch over to the word slide. Really what we're looking at is building partnerships with collaborators across NC State as well as North Carolina and even internationally as well. Currently, we're working with mechanical engineering, psychology, civil engineering, working with NC&T, Duke, and the Highway Safety Research Center at UNC. We have active projects working with NCDOT and USDOT, and we're actively developing proposals under NSF programs, DOE programs, as well as looking ways to, again, build the team basis that we've started further through institutional funding. So why am I here? I'm really interested in hearing about all of your research, as well as seeing if there's any opportunities, again, for collaboration. That may be just us finding out what you're doing in the field and using that as a great pitch when we go to sponsor agencies to show the value of working with NC State. It may be that you could use subject matter experts in the transportation field to come alongside you in your projects. We can definitely assist in that side. And we'd also love to, again, work on full team building as well to build collaborative proposals. So I'm poster number 12, and I'd love to talk with you guys about your interest. Thank you.
Good afternoon. My name is Aranza Sue Laskarine. I work for the Southeast Climate Adaptation Science Center. It is a federal university partnership. NC State won the bid about 8 years ago to host it here, and it is funded through the U.S. Geological Survey. The one here at NC State is one of 8 centers across the United States, all housed at public universities. And our mission is to look at the impacts of climate change on wildlife, fish, and ecosystems, and to prepare the tools and scientific data to co-produce that science with natural and cultural resource managers. So here's a map of the territories in which we work, including Puerto Rico and the U.S. Virgin Islands. I wanted to make a pitch that we run an annual request for proposals of $1 million on average per year to fund NC State faculty and our USGS colleagues. And very importantly, I wanted to talk about our Global Change Fellows Program, which we've been in operation about 8 years. And if you can see there by the numbers, we've funded about 68 fellows across 7 colleges, 12 departments. The idea here is to bring together graduate students to think about the multidisciplinary approaches to climate change and to work across these disciplines, to know how to communicate with each other, and to really train the next generation of scientists that we'll need in a changing climate. So I'd love to talk to you. I'm at poster 13, and I'm especially looking for other disciplines to join us, other faculty. We run the selection process for the students every year. We just now finished selection of those students. We have a wonderful incoming class, and I'd love to talk to you more about doing analysis on how well these programs work. So I look forward to talking to you. Thank you.
Hello, my name is Cesar Delgado. I'm an associate professor in STEM education, and my area of research is how students understand and learn about the magnitude of variables, so temporal and spatial dimensions. And I know that that is probably an issue that you have encountered in your classes. If you're in the realm of things that are very large, very small, or take a long time, or take a very tiny amount of time, perhaps we can collaborate and figure out how to help your students understand better these difficult issues in temporal and spatial scale. My poster is over there at 14, and I hope to talk to many of you.
So at this point, we're going to give everybody the opportunity to stand up. It's our first poster session, and we will reconvene for our next set of talks starting at 3:10.
didn't want to touch it and blow it up.
Testing. Testing.
Testing. That works.
Testing. Okay, everyone, it's about time to start the second half of our program. If you can take the next few minutes, take your last pictures of posters, and let them know you're going to see them again at 5 o'clock, and come back over here and take your seats.
Testing.
All right, looks like we're ready. So it's my pleasure, I'm Gail Jones. I'm from the College of Education. It's my pleasure to introduce Dr. Ann Ross. She comes to us from the University of Tennessee, and she's currently a professor in the Department of Biological Sciences and is the director of the Forensic Sciences Institute at NC State. So join me in welcoming her.
Hi. Good afternoon, everyone. So today I'm going to talk to you a little bit about forensic anthropology is my area of specialty. And one of the things that we do is to work on cases. So actually, if you looked at your little cards, we would fit under the first strategic plan. I guess point would be creating safe, secure, and intelligent systems. So what we do is actually we work with the law enforcement in the state of North Carolina, and we also work with the NC Office of the Chief Medical Examiner working on forensic cases around the state. So when you have, we are hard tissue experts. So anytime that you have any kind of trauma or anything else that's going on bone, those cases actually get sent to us for consultation. But one thing I also wanted to bring up is that one of the things that drives forensics in general and forensic science in general is the federal court ruling of Daubert versus Morale Pharmaceuticals that was in 1993. And this court ruling talks about the admissibility of scientific evidence in the court systems. And it also refers to what it means to be an expert witness. So some of the things that they actually list out that you need to have peer-reviewed publications, that your methods are peer-reviewed, that your methods are validated, that you have error rates with your methods that you are using in court cases. And also, if these methods that you are using, are they accepted by the discipline or the community that you're dealing with? One of the things that came out in, as you can see, in the journal Science is forensic science an oxymoron. This actually set about a complete congressional investigation as to the forensic sciences, especially evidence, for example, the ones that are in law enforcement offices and the FBI, whether it's fingerprint analysts. Another thing that and what happened with that is that they were seeing that there was no direct relationship between universities and research and some of these people or practitioners that were actually conducting this kind of work. And one thing that they also realized is one of the ones that were very hard hit at the very beginning was fingerprints. The issue was, it's not that fingerprints are unreliable. The problem is that it had never been validated or its reliability had never been tested. So you had examiners that were identifying people, and there was no consensus as to how many points of concordance actually amounts to an identification. And we're dealing with identification of a perpetrator, setting someone in at the, establishing whether this perp was at the crime scene, and so it went into all these sorts of things. So then we had this congressional hearing decided that the National Academy of Sciences, and they conducted this report in 2009, and their report really hit hard on most of the forensic sciences. Luckily, in my discipline, we've been doing error checks for many, many decades now, and one of the things that we do establish is error rates and probabilities. We use Bayes' theorem to assess, probabilistic models for the work that we do. And one of the things now I wanted to point out too is that not everyone is a Daubert state, right? This is a federal court ruling. North Carolina became a Daubert state in January 2014, so we recently became Daubert, which was an amendment to the ruling of NC 702. And that would mean it's kind of like the Fry system that a lot of other states are still under, and that means at that point, the judge is still deciding who the expert is, and they come in to testify in court. But under the Fry, it's a little bit loosey-goosey, so you can say, well, because I have 20 years experience, that makes me an expert, not because I'm using, the appropriate methodology when assessing a case. The judge is still the gatekeeper, so the judge still decides and gets to determine what good science is and what bad science is. But recently, in I think the last couple of years, the FBI also had examiners looking at hair and hair identification of perpetrators. And the Innocence Project and the National Association of Criminal Defense Attorneys did a 3-year review, and they found that 26 out of 28 examiners at the FBI overstepped their interpretations of hair identification. And a lot of people ended up actually here, we had 32 defendants that were sentenced to death, and 14 had already been executed by the time that this report came out. So that's one of the things that we have to really be careful as practitioners, is to not overstep your bounds, especially North Carolina has one of the highest death penalty states in the country still. And that's something that we always have to keep in mind, that not to overstep or overwork for the prosecution. And a lot of things that happen when you have law enforcement working directly with prosecutors and they're doing the science and they're doing the research, it's very biased, right? And one thing that you have to remove that bias, because essentially they're making the data fit for what the prosecution wants to prove in the court. Another thing that I feel very strongly about, actually, is we have a professional responsibility to keep junk science out of the court systems. I hardly ever work for the defense, but I will get involved when I see junk science happening, because that is one of the things that we have to be very responsible about, not allowing these sort of things to even get through the gatekeeper, right? Because judges and lawyers are not scientists. So you have to show them what the right science is and what's the wrong science. Like I said, many states are not a dauber state. I actually worked recently in Virginia, the Commonwealth of Virginia, and they're still FRI, which is shocking to me. But that was very interesting, and they allowed a case that I actually worked for the defense on, a couple that their baby had died, but they were seeking the death penalty. However, they allowed somebody that had no credentialing in forensics to come in and testify in this court case. And so one thing that I always think you have to keep your moral compass on is, like, you're really going to send someone to death row because it's for kicks, right? So this is a case from North Carolina, out in Forsyth County. Ms. Rodriguez, I actually took all the gory pictures off of here, so don't worry, they're all gone. Ms. Rodriguez was found in, I think it was November. She was reported missing. Her body was found on December 1st. They had contacted Dr. Vass out of he's at Oak Ridge National Laboratories in Tennessee, because he does like the odor of decay. And he set up a postmortem interval. So this case had gone on for a few years, so we had to do a postmortem interval based on crime scene photographs. And one of the things that he had was he was basing the postmortem interval to fit within the time period, because Ms. Rodriguez had been found decapitated, naked in the woods. So they were trying to get her husband on death row for this time, and what they were trying to do is make sure that he was out of jail during that period of time, so they can actually, he would be found guilty for this crime. One of the things that he did is that his study is based on his dissertation work from 1992, based on 7 bodies. So we had a pretrial hearing, and one of the things that the judge, because we had this is 2014, become a Daubert state, he was asking him the right questions. Do you have error rates? What are the probabilities? I said, you have a sample of 7 individuals. How can you say that? How can you come up with an equation with just a small sample size? And the judge had asked him, it's like, okay, well, how do you know this? And he's like, well, I've seen hundreds and hundreds of dead bodies. Well, if you have, why didn't you change your study and add those to your study to come up with a better, robust equation? So she had been reported missing November 19th. She had been decapitated. Body was found December 12th. And what we look at is entomologists. We look at temperature, because one of the major drivers in decomposition are insect activity and also moisture in the soil moisture. So we found that the temperatures had dropped on December 2nd She had fixed lividity. Fixed lividity happens within a few hours of the death of a body, and that's where you get that reddish. I had pictures, but they're too bad, so I didn't bring them. Where when you're laying on a certain, let's say if you're laying on the ground, the areas that the blood pools in the areas where you have been laying it. So you can assess the lividity and actually kind of get a semi-estimate of time since death. She had no bloating, so she was at very early stages of decomposition. There were no fungal reaction. There was no greenish discoloration in the abdomen, and that usually begins approximately about a week after death due to putrefaction, where you're decomposing from the inside out. There was also minimal scavenging activity, and remember she was decapitated, and also there was hardly any maggot activity. And based on the temperatures for that year, we got it from the weather station that was pretty close to the site where she was found. We should have seen a significant amount of maggot activity, especially at the site of trauma. So you always know there always come to the orifices and sites of trauma that you can assess. So Dr. Vass said that she had been out there for 16 to 20 days. Our assessment is 4 to 7 days, maximum 10 days, based on the weather data. So what happened here, and this is one time that I worked for the defense, he was actually barred from the North Carolina trial. They were going for the death penalty, and this actually came out in the newspaper, so I'm sure he was a little salty about that. But these are the sorts of things that as a having your moral compass, that we really should keep this kind of junk science. And he's the one that had worked on the Casey Anthony case in Florida, the little girl that went missing and died. And he testified on the odor of decay, and that he had smelled the decay that they had collected in some vial that they sent to him to get her. And that's why that case, she never got convicted, because they had a lot of this kind of junk science going on. Another thing that we do also, we don't only get rid of junk science from the courtrooms, but a lot of things too, we help our chief medical examiner on some of our hardest cases. Unfortunately, we have an expertise here in North Carolina on child fatalities. One of the other things that we do here is we assess fatal starvation, which is one of the hardest things to assess, even if you have an intact body, is to assess fatal starvation from skeletonized remains. And usually, these types of child abuse cases, especially fatal starvation, are from infants to about 14 months. It's usually the last child in the family. And they're based on low socioeconomic status. There's some mental health issues. It's usually the last child in the family that has this sort of thing. And when you actually go to the home, there are other indicators. Garbage, there's no infant or baby food really available, even things like dead rats on the countertops. So I mean, it's a really sense of decay that the family has. This young man, he was an airman. He pled guilty to killing his toddler son. His wife had left him. He would go to work. And unfortunately, a lot of the fatal starvation cases that we have are with our law enforcement, are with the military here in North Carolina. He would leave the 14-month-old with bread and water and leave for 8 to 10 hours a day. Then he met some lady online, decided to go away for the weekend and leave him behind, and when he came back, baby Theodore was dead. He then proceeded to dump him in a garbage bag and leave him on the side of the road. So one of the things that we're doing here in North Carolina that we are not using anywhere else really is using bone mineral density, because bone mineral density is directly associated with age. So it increases with age. There's a direct correlation with age and bone mineral density. And this is something that is used in developing countries to assess malnutrition because it's low radiation. So one thing that we were able to use and assess, yeah, there it is. You see here? Right, so this is a 95th percentile, and you would hope that he would be, at least in the 25th percentile range, right, to the 50th percentile range for bone mineral density. He's off the chart, right? And we know that boys and girls, it's a linear relationship. It increases with age up to about 10, and that's when boys and girls start differentiating with bone mineral density, and then we look at them differently. And then we also know we can use bone mineral density to age adults as well, because it really does go down after you hit 30, so your bone mineral density starts. It's a negative linear relationship with bone mineral density as you age as well. He was court-martialed. He was sentenced to life in prison, and he got dishonorable discharge as well. This is another thing that we've done here. This was a recent case, and I'll finish up quickly with this one. Son went into the crawl space to put up the cable. His mother had lived in the house and his sister had lived in the house. He freaks out. He finds a body bag with 2 dead babies in it. She's a drug addict, heroin addict. She says, I was doing drugs and they were stillbirths. So this is something that we can use. It's called the neonatal line. It's also, our lab here at NC State is one of the only ones in the United States that is using this. Those who are mothers out there, the process of birth is traumatic, not only for the child, but also for the mother, as we all know. But that trauma is actually scored on the teeth. So, and we can use the neonatal line as evidence of a live birth. So every mammal has this, dogs, cats, you name it. Every mammal has this neonatal line if it was a live birth, if it was a cesarean section, all of these things. So if it's a live birth, you have to live 3 to 4 days in order to be able to see that line though, right? So if the line is missing, doesn't necessarily mean that there was no infanticide, but in a lot of these cases, we can. And so it's enamel related to growth. It's an accentuated stria of Retzius. We can look at it histologically, and this was discovered back in 1936. So a normal neonatal line is about 12 micrometers wider for operative or premature deaths. So what we're looking at here, this is a cross-section of a deciduous dentition. And so we're looking at the line, so you have prenatal enamel, and then you have postnatal enamel. And we're looking at this, it's this black line right here, and it's this line back here. So baby doe 1 was around 36 to 42 weeks when we aged him skeletally, right? It's around normal, right, to term. We couldn't get the ages closer to that. But the fact that he had a neonatal line was the fact that there was a live birth. So they also investigated this woman because obviously it was not a stillbirth. Baby number 2, also the neonatal line right here. This is a cross-section of a tooth, and there it's right there. We estimated this baby to be about 38 to 40 weeks. Also was alive. And just to say, this woman had been known to have been pregnant 11 times, but there are only 3 live children accounted for. All right, so this is something that she did quite a bit. And the ME ruled undetermined cause of death, but homicide, right? Because we don't really know what killed the children, but she obviously ruled it a homicide. Another thing that we have applied, our medical examiner sometimes think that we can make wine out of water, and you get 3 scrappy little pieces of bone, very weathered. North Carolina soil is not good for preservation. You will be completely obliterated within 30 years. It's the acidity of the soil, it's the clay soils that we have are not very good for preservation. So the story for this case is this young man, actually a young man goes out by Cary he went running. He finds a wallet, takes the wallet home because it had an ID in it. He looks up on the computer this name and he realizes this person had been missing since 1992. So then we go back and we were able, so I'm trying to see, obviously it was a young man, age of 20, but you can't assess any of that based on this. So the first thing we did is do a radiocarbon test, a post-bomb test. And the radiocarbon is like when they were doing the atomic testing back in the 1940s, the levels of that layer in the atmosphere actually get stored in your bones. So we can tell whether you're post-1950s or pre-1950s based on the levels of carbon-14 in your remains. So we found out, obviously, that he was modern. The next thing we had to do, based on the levels of carbon that are, where are they? It's like right up here, right here, in the bones, was to assess. We tried to figure out year of death, that you can assess year of death. And how did we do this? We used the lag time because he was 20, and the lag time for someone in their 20s is 11.9 years. So we add, this is the year that the beta analytic or the lab that sent it to us for carbon-14 said. So we add 11.9 and we got 19.93 estimated year of death. So we were able to say that the remains were consistent with this young man, and he was actually then identified via DNA. So that was him. And the story with him was he was 20, he had come to Raleigh for a Grateful Dead concert. He had dropped a little too much acid. His buddies left him, and then they went back to Florida and left him, and he disappeared, and they never found him. Let's see. We can also calculate year of birth using teeth. So for this case, we didn't know the remains had been burnt down in a house, and they had been abandoned for a few years. We needed to assess year of birth and also year of death. So here, what we do is use the same carbon in the teeth, and the reason why we use teeth, because the crowns of the tooth are set in early years, and they don't remodel, whereas the rest of the skeleton remodels about every 8 to 10 years, right? So that's why we use teeth here. And so for someone, so the second incisor that we used, it's 4.4 years, I think, so we were able to trace it back that his year of birth was 1976. And then we were also able to say with 91.1% probability that the year of death was between 1996, I think it says, to 2000. So we were able to get a timeline for this person, so hopefully at one point we will actually get an identification. So that's another part of the work that we do. That's one of our primary human rights, your right to personal identification. So that's one of the things that we work with all of the unidentified border crossers here in the US and also internationally, is to try to give people back their names. So we're going through every cold case in the state right now for all dating back to the 1960s that we can actually give a name to some of these people. Another thing that we have done here, and I don't know why North Carolina has such a high frequency of dismemberments, but we do. This is Ms. Smith, and as you can see, these are her femora, proximal femora, and what we did was we used a pig proxy to test the saw that was used, and when we look at it under the microscope, this is the victim, and here's the saw, and you can tell it's consistent, so that was a match. And he pled guilty, and he's serving life in prison. This is the saw that we tested. A lot of times, either they find it at the scene and they let us use it to test it, or sometimes they have found receipts that they go and buy the same saw for us, or sometimes we don't know what it is and we have to assess the type of weapon that was used. Any questions? Yes.
So this is a philosophical question. So how do you sleep at night? I mean, how do you disaggregate yourself from this work?
Well, especially with, that's a really good question. With the kid cases, you don't sleep until the case is done. You always take it home, right? You mull over it. You think about what's another way that we can actually assess something, or did we miss something? So yeah, and the way I see it too is like we're their only voice, right? They have no one else, so you're their voice, and you have to speak up. Thank you. Yes.
present a lot of case studies using different technologies to assess what's going on. Where do you stand in actually developing the technologies? And how do you go about that?
Good question. Now, one thing that we just published, and we have a National Institute of Justice grant, is using bone mineral density to, one of the hardest things to do is aging adults, because after you hit 30, all of our aging parameters are based on degenerative changes of the joint surfaces, which is not an intrinsic factor. But we know bone mineral density, which is intrinsic, and that is something that we're actually using the NHANES data to do that in a large sample of over 14,000 individuals. So we're developing new equations. So one of the things that I do is develop new equations for, let's say, for stature or living stature from skeletal samples that we have. So we develop new standards for identification.
I guess I'm not asking more about how do you reach outside of your area, your center, your activity. How do you find people to help develop new tools?
That is based on, I call it case-driven research. Every case is different. So anytime that we have a case that is complicated, that's when you start thinking outside of the box. And that's how we reach out to other people. Because we work with entomologists all the time on the postmortem interval.
Well, there you go.
Yeah.
There's an example.
Yeah.
What about other groups?
One thing that we're trying to assess is pattern analysis. So we actually, with our cluster, we have a young man who does digital forensics. And hopefully he'll be able to help us with that. Yeah. Yes.
Can you say a couple words about, I mean, you've done a lot of analysis here. What about the analytical equipment or facilities you have versus the shared facilities at the university? Do you make use of a lot of the shared facilities at the university, or you have your own facilities?
I have my own microscope, my own bone mineral density scanner, and for carbon-14, we send it out to an ISO lab. So everything in forensics has to be like ISO this and ISO that. One of the things that we have issues with is chain of custody. So we have to know exactly where that piece of evidence is at all times. So that's one of the, if we can use shared facilities as long as I'm sitting there next to it for the entire process. But if it's something that takes days, so for example, the histology actually gets done in Dr. Schweitzer's lab because she has a closed access facility that we can actually make sure that the evidence or the chain of custody is not broken.
Let's give her a hand. Thank you.
That was amazing. Well, we're going to switch gears a little bit and now have a panel conversation, not a discussion, a conversation. And so it's my pleasure to introduce Matthew Booker from the College of Humanities and Social Science. So Matthew.
This would be a great time for all four of our panel members to come up. Kranos Williams, Jason Delborn, Elizabeth Nelson, Fred Gould. And take a chair. That was kind of heavy, and actually I'd just like to take a deep breath. And I'm really impressed by the work you do, Dr. Ross. It was really quite remarkable to hear that commitment. I appreciated the questions. So the plan for this panel, this roundtable, is to offer something a little different from what has come before. When the committee was discussing how to think about interdisciplinary research, several of us asked about the process of interdisciplinarity itself, about how relationships are formed, about how they are continued, and several of our speakers have actually either spoken to that or asked about that. All of the people who are sitting in front of you today have active interdisciplinary, cross-disciplinary, or multidisciplinary research projects, sometimes with each other, as we will see here in a moment. And so the plan is for me to introduce our panelists, And then I'm going to ask each to speak for no more than 4 minutes, about the intellectual challenges and rewards, intellectual challenges and rewards. There are lots of challenges and rewards for research. We've heard some of those, including funding and so on, or structural disadvantages. But I want to think here, we want to think about intellectual rewards and challenges of interdisciplinary research. Laura, you're going to be our timekeeper, right? You're going to flash us the 2 minutes? Okay, I'm going to flash us the 2 minutes. So I'm going to introduce each of the panelists, the members of this group. Then my fellow moderator, Fred Gould, and I will ask some follow-ups. And then we're going to turn this panel into a conversation with you, the audience. I suspect that you're a self-selected group, that you are already doing or are interested in doing interdisciplinary work. And so this should become a conversation about the rewards, the intellectual rewards and challenges of doing that work, a conversation, so it's not just a panel. So I'm going to start with Fred Gould, who's on the far right here. Fred Gould is the godfather of interdisciplinary research and graduate training at NC State. And I mean that with love, Fred. He is the Reynolds Professor of Agriculture in the Department of Entomology and Plant Pathology. He's a founder of one of the first interdisciplinary research clusters at NC State, now the Genetic Engineering and Society Center. Fred recently chaired the National Academies of Science report on genetically engineered crops. I'd like to thank Fred for being my co-moderator and thinking with me about this panel. Next to Fred is Kranos Williams, who is Associate Professor of Electrical and Computer Engineering and Director of the NBISIS Research Lab here at NC State. The NBISIS Lab is a highly collaborative, multidisciplinary research laboratory focused on the development of models needed to manipulate and control biological systems. Kranos has a research effort with Dr. Ross Susani in plant and microbial ecology, who could not be here today, so he's going to speak on behalf of both. Next to Kranos is Elizabeth Nichols. She's a professor in forestry and environmental resources and associate faculty with the Department of Environmental and Molecular Toxicology. She's a toxicologist whose wide-ranging research on forests and waters is driven by an effort to protect surface waters and groundwater quality from point and non-point sources, as well as ensuring forest landscapes for the future. That's a very nice line, by the way, from one of your websites. She has a research effort with Jason Delborn, who's also in the College of Natural Resources and is sitting next to her. Jason is Associate Professor of Science, Policy, and Society in the Department of Forestry and Environmental Resources. He's a founding member of the Genetic Engineering and Society Interdisciplinary Research Cluster. Jason is a social scientist with expertise in environmental policy, among other things. So like Kranos, Elizabeth, and Fred, Jason has many achievements, but I'd like to recognize his recent naming as a university faculty fellow. Congratulations, Jason. Okay, now I'm going to sit down. Will you be our 2-minute person after all, because you're way better at it? Well, thanks. So what I'd like to do now is ask each of our panelists in turn to speak for 4 minutes about their research collaboration, focusing on the intellectual and on the intellectual rewards and challenges. So Kranos, could you reflect on your partnership with Ross Susani in plant and microbial ecology? And especially what I'm interested in is, what is the goal that you have together? Why did you reach out to one another across those disciplines? And what have been the benefits and rewards and challenges intellectually?
Okay. Wow, 4 minutes. So, in truth, I first met Ross during an interview for the Systems and Synthetic Biology cluster. So this was something that had emerged, the cluster itself had emerged from initiatives from myself and several other faculties, and we submitted it for that award, and it eventually got funded, and Ross was actually one of the first interviewees. And immediately, Ross stood out. She definitely stood out as an interdisciplinary researcher. She's in plant biology, but has a knack for asking the very tough questions. And pretty much I had been working in that area for probably about 3 years before that. So this is back in 2012. So ever since then, we've been working together on several initiatives, co-mentoring of students. We actually developed a cross-listed class that's cross-listed between ECE and plant biology, which really you don't really find very often, focused on modeling various levels of biological systems at the metabolic and gene regulatory levels. We've co-authored several papers. We actually funded through the same innovation grant that Ralph was talking about earlier, focused on developing nanosensors for sensing and manipulating characteristics for stress responses in plants. And a lot of those interactions pretty much emerged into this large-scale collaborative effort that we're working on now, which is focused on a proposal for an engineering research center. And it is a research center that is focused on advancing the discovery and innovation and education for next-generation agricultural solutions. So it really composes not only the research that Ross and myself are doing, but also the research of many other faculty members, Mike Kudinoff, who works on imaging and high-throughput phenotyping, Ralph Dean, as well, for working on VOCs, volatile organic compounds, and several other faculties in crop sciences, the GES, actually, and even a pool college of management. So it's just emerged and transformed into what has been a very intellectually rewarding experience. Oh, I still have 2 minutes. This is the alarm that I set for myself to turn the alarm off for my son when he gets home from school. So just happens to be 3:45. So, and you asked about, well, what are some of the things that are the most rewarding? Honestly, the great thing about working with people like Ross is the immense patience that everyone in the room has to have. You really have to be comfortable just not understanding, and in some cases being lost. And in some cases just saying, I don't know. And it's sometimes hard to find those people, but when you find them, you really tend to latch onto them because the communication gets easier, not because the problems get easier, but because being able to talk to one another gets easier. Being able to admit that you don't understand gets easier. Being able to try to shape things such that everyone can understand, not just the people who are specialists in your area, gets easier. And that in itself is particularly rewarding. And in the case of this engineering research center, we're really focused on very big visions in terms of enabling or developing the engineering technologies for enabling long-term food security. Really focused on improving aspects of pre-harvest resiliency, post-harvest food quality, and food safety. So that in itself is a very big problem and is rewarding to be able to get all of those people in the room. I was looking at my time. To get all of those people in the room to be able to address those types of problems.
Thank you. That was really thoughtful, and I think we'll return to some of the points you made because there's a lot of nodding happening up here. Elizabeth, could I ask you, why did you join with Jason Delborn, a social scientist? What is the goal of your partnership, and what have been the intellectual rewards or challenges? And I'll give Jason a chance to rebut later.
I think I have to first honestly admit that Jason's not my first social scientist to collaborate with. Why did I join with Jason? Because the project and the work that we wanted to do required that element. I think a lot of people in this room are creating great science and technology, but there's the human dimension of implementation. And the world that I was working in with wastewater and forests and treatment requires understanding how communities perceive potential changes in the future. And the experts in the room, which are in this room, or experts working for municipalities, in the world of water reuse and water security, we have to understand that we have to be engaged collectively as a community to make these changes for sustainability. So when I was reading this RFP and I thought that I was well positioned for it, I knew I needed a social scientist. And Jason had just shown up. And I recruited him or asked him to do it. He was a little hesitant, but then he came on board. And I think the rewarding part for me is learning about the other disciplines. I think one reason we do what we do is we enjoy learning. And in the past, I've worked with some other social scientists and seeing the implementation in the field for their methodology and learning through that process. I'm not going to do Jason's work, but I enjoy the collaboration to benefit from it. And I think, to me, that's the biggest reward are the different perspectives and the different insights that we bring to the same issue.
Thank you. That was also full of nodding on this panel, so I'm going to come back to at least one point there. Jason, what made you interested in working with Elizabeth, whose methods and disciplinary expectations are so different, even though you do share a department? What did you see as the rewards and challenges intellectually?
Also, not my first rodeo with a natural scientist. I mean, I really enjoy that kind of work as a social scientist. My field is science and technology studies, so I think about the relationships among science, technology, and society. And part of that is thinking about the way that science and technology enter our world and how the world shapes the science and technology that gets done. So to partner with Elizabeth was a natural fit for me. But we don't always get what we expect out of these kinds of collaborations. So the initial ask from Elizabeth was, we know that changing the way that municipalities might manage their wastewater is going to be controversial. And so as we're seeking to figure out whether there are more sustainable solutions than the standard, we need to think about the way that communities are going to react to those changes. And so that seemed like quite a reasonable reason for me to be involved in the project. And so what we did was we made the whole research project more participatory. So we have a participatory leadership team that has community officials and people who work at the wastewater treatment plant and farmers in the area to be part of regular meetings about how the research gets done. And they help us deal with a broader community involvement group who we report to about once a year, where we can experiment with ways that we talk about the science that's getting done that I don't understand and I could never do. So there's that broad kind of framing of the study that makes it more participatory, but then little possibilities emerge when you're involved in work like this. So one of the things that I was noticing is that their techniques, which I can't explain to you, are very exploratory in terms of testing water, not to find a particular substance, but to scan the sample for kind of traces that could point to a lot of different things. And with some amount of certainty, we can say this is likely to be this or likely to be that, but we don't know how much is in there. We just know that it could be there. And if you think about that, that's terrifying science to produce, because you tell people who live in a community, we've tested your water and there could be all this different kind of stuff in your water. And we can't tell you how much, and we can't tell you if it's dangerous, and we're not even sure we can verify it. But that's the science they want to do. So that's a pretty complicated problem that I'm thinking about as part of this project. And so one of the things that we did in our last community involvement group, and this was a collaborative idea, we said, what happens when you present this preliminary data and emphasize the uncertainty versus the certainty? And so we actually split our community group into two sides of the room, and one scientist who understands the technique gave the presentation with all the same slides, but emphasized the ways that we were uncertain about what we could say. And the other side of the room presented the same slides, but talked about what we were certain about. And so what we're doing now is we're looking at the data, which is the conversation among those people, and what they said in the larger group according to those different kinds of treatments. And that's not, a double-blind, careful experiment, but it can give us insight into the way that folks out in the community would respond to this very complicated research that is uncertain when we emphasize different things. So we're experimenting in real time to figure out how to communicate the kinds of results that Elizabeth and her team are producing.
So, Fred, before I ask you to come up, before I ask you to speak, I actually want to follow up with your permission, with everybody's permission, on 3 themes that I picked up, and everyone can respond to these. So the 3 that I picked up were uncertainty, experience, like not having your first rodeo, and Kranos, you said something really interesting about teaching. So I'd like to ask the 4 of you about those 3 themes. Handling uncertainty in research, because Jason, that's not just a problem for the communities in which this research is conducted. It's a fundamental problem for the researchers yourselves, right? How do you, for example, you admitted that you cannot understand fully explain some of the techniques that your partner is using. And that's just a natural part of doing interdisciplinary research. There's one theme. A second had to do with the fact that several of you appear to have worked together with people outside our disciplines before. How that habit first gets started interests me. And then Kranos, you said something about teaching, and that is, to me, in some ways, the gold standard of interdisciplinary work. Frankly, I've seen this at NC State. It's really hard to teach together across disciplines. So, wanted to throw those 3 themes out. Any of the 4 of you can have at any of those themes.
Okay. Yes, it is challenging. And it's challenging for a lot of reasons. It's, there's the obvious challenge of trying to just coordinate. Even if you had 2 people that were teaching a class from the same discipline, just being able to coordinate activities, coordinate teaching styles, et cetera, that in itself is difficult. But then you have the ability, or sometimes inability, to convey material such that even the person that you're teaching with understands. And having the resilience to go back and modify or change what it is that you're doing. Even if I've taught this class before, the way that I'm now teaching it in this interdisciplinary environment, I need to emphasize and convey things in a different way. The other major challenge is the difference in students from year to year. So like I said, it's a cross-listed course. So thus, there are students from ECE in there, there's sometimes students from biomed, ag and bioengineering, but there are also students from plant biology, there are also students from biochemistry. Some of these students have never heard MATLAB before. There may be people in the audience that may have never heard of the term MATLAB before, or an ordinary differential equation. So now, how do I convey at a high level what these concepts are so that I can drill down into the details that they're gonna need to be able to implement everything else? So that requires 2 people or multiple people that are very adaptive in terms of how they convey material, how they convey information, and are willing to switch things up. One time we gave the lectures in one order and we saw the response from the students, was not in an acceptable way where they were getting the information that we wanted, so we changed it. So being able to do that and being able to have this partner, that you're working with that would be open to doing those type of things. And then it's being adaptive to the students' responses. I mean, when you stand up there and you start saying concepts and you see nothing but blank looks on people's faces, or you have the very weird situation of half the class is doing this and the other half of the class is doing this. And you have to be able to notice this and see this. And in some ways, sometimes be a counselor to the students that are not understanding the material, to be able to say, well, look, if you work with me, if we go through this process, by the end of this class, you will be able to communicate at a level where you understand the material, and you will be able to communicate with everybody in this class. And having people trust that process and seeing the look on their faces when it actually happens. We've had students in there that, I swear, we had one student in there, she looked at ordinary differential equations with a sense of hate that I really don't see very often. But by the end of the semester, she was running simulations, she was, doing everything else, and not only that, I was on her committee. She was then putting forth meaningful questions from her research and the overall research project, driving us, asking us, well, what if I were to give you these type of data? Could you do this? And that was the best transformation I've ever seen in my life. And so you say, some of the rewarding things, that's one of them. So those are my experiences in that realm.
Thank you. Anybody want to take on that question or one of the other 2 or topics?
I think I'd like to speak to uncertainty. And I think, to be truthful, I like uncertainty, I like risk. Perhaps I've been too risky in my past life, but I find that engaging. And the thing about interdisciplinary research that I also appreciate is bringing that together with diversity. And I think that really is the key for innovation as well as future convergence. And all those things mixed together, I think, just make for a high degree of uncertainty, which I find enticing because you don't quite know where things are going to go.
Jason? That leaves me with the experience one, I guess. Thanks. I mean, I'll just say something which I think is fairly simple, which is that, you know, once you've had experience doing this kind of work, you develop a respect for the kinds of expertise that you don't have. And you have to grow comfortable with knowing that you're not going to grasp everything right away. But it's so fun to begin to learn it enough to be able to have a conversation with an expert, even if you can't attain that expertise yourself. And then the other part is having the self-confidence that eventually your expertise is going to be relevant too. And you know, I think all of us have a hard time, you know, knowing exactly what do we know? What is our expertise? I mean, the imposter syndrome is rampant in universities. One way to deal with that is to be in an environment where your expertise is a little bit unique, and you can discover in yourself what you have to contribute and what are some of your skills, and have some of the assumptions that you might have about your own discipline questioned. And when you have to explain them to a colleague, then you're really understanding what you bring to the table. And so finding those opportunities is actually quite exciting. And you just have to kind of sit with it and, you know, be confident in your partner and confident in yourself that you can work through it.
Yeah, a lot of that echoes for me too. So Fred, I'm thinking about time. I know that you are ready to do something a little bit different. Fred, you've thought a lot about interdisciplinarity, and so you and I talked about how you might address that, and I think you have visuals, right?
I think I do, huh? All right. Well, Matthew was involved in this as well. Can you hear me all right? Yeah. I've had quite a bit of interesting experiences with interdisciplinarity, and I would just, what I think is interdisciplinarity, but just to sort of say that one of the things I just want to say is that in terms of interdisciplinarity and what it does for you, I've been here this is my 41st year, and I'm in the entomology and plant pathology department. I have colleagues who are retiring. They're tired of teaching the same course over and over again and being the same thing. Interdisciplinarity opens up NC State. There's a door in every little way, and you're just in the same place, but you're entering all these new doors, and the challenges are amazing. But we've had these conversations about what is interdisciplinarity. And we actually, with the Plant Science Initiative, some of you know, we sent out a questionnaire to ask our faculty what they thought was interdisciplinary, cross-disciplinarity and all that. And some people wrote back that they thought the whole thing was just a bunch of buzzwords, and they had been doing this for their whole career. And I think that forestry and environmental resources, where you folks are, is an example of that, because if you want to solve a problem, and we've seen this today, you need that. So Matthew and I worked on a little project here that is a little bit of levity, but instead of trying to define it, we asked this question about how do you know if you're really involved in interdisciplinary work? And so the first one was when you start using someone else's jargon. You know, so how many people have experienced that? You know, in the beginning, as all of you have been saying, you know, like there's all this jargon. Do I understand what I'm saying? Once you start using the other person's words, you know you're doing something in interdisciplinarity. When you want to go to more than one seminar a day on campus, I mean, come on, a lot of you probably have had that experience, right? You know, in a while, you know, you go to your department seminar once a week and so on, and then all of a sudden things are opening up, right? Okay. When you have to work hard to follow the methods section in your graduate student's thesis, right? I mean, again, you know, a lot of us are experiencing that because we're grasping so much, and it came out in this conversation. Another one, when you clock over 10,000 steps walking from one building to the other. We're going to ask you folks for more of these when we're finished here, okay? When you're not sure which of multiple department holiday parties you should attend, right? You folks know this. I know you're laughing because you know this. And I'm sure this is a self-selected group. Okay. when you're no longer surprised by the fact that the structure of your department's graduate program is seen as bizarre by your colleagues, right? How many of us have departments where for a full year, all the students have to take this whole set of required courses, and then you go over to the next department and they have no required courses in the department? You know, right? How many of them you come in and you have a major professor or you can't come in to the department, and how many have rotations you're not allowed to have it, right? How do we, you know, facing these things? Interdisciplinarity is not easy is the deal on that part, okay? When you give up trying to figure out which department gets credit for your teaching. All right? When you can remember more than a handful of times when your most cherished paradigms were shown to be flawed, right? And I think all of you on this panel know that. I always say that when I really recognized I was doing interdisciplinarity is when I would get so angry in a workshop because I found out that they were right. You know, I mean, it's hard sometimes, you know, you have this ego. And I think that you were talking to that a lot, right? Because you go and you don't understand, how do you do that? And when you can't figure out how to introduce yourself. And when you know people in every college on the campus. And then when you sit on more doctoral committees outside your department than in it. And now, what else? I know it's putting you on the spot, but what tells you that you're changing and you're doing this? Yeah.
So Laura has a microphone, and she's asked that we pass around the mic if people in the audience want to start answering this question too. But first, I think Kranos has an answer.
One to add to that, when you walk into a doctoral student committee and you have to really figure out which rules you're going by because they change from department to department.
Yeah.
When you choose which journal to publish in, not because it does something for your disciplinary ranking, but because it's the best journal to publish that result in.
When you pick a research method to solve a problem that you really don't know how to do, and you've got to struggle to apply it.
Where do you want to go from here? Do you want to just open it up to other people's experiences?
When your LinkedIn profile title is a sentence instead of 3 words.
Go ahead.
So any more thoughts about that question from the 4 of you up here? Any additions?
It's a good list.
It's a good list. Okay, so we set aside 20 minutes. We have 17 minutes and 47 seconds, not bad, for conversation with you about this question, about the question of interdisciplinarity and what its intellectual rewards and challenges are. And so I suggested earlier that you're probably a self-selected group. I think that's been proven true in the 2-minute lightning conversations where people solicited help from others or engagement. But I also know that people in this audience represent a wide range of interdisciplinary initiatives and collaborations on campus. The 4 of us, the 5 of us, represent some of those collaborations, but I really wanted to give, the committee wanted to give this opportunity for the audience as a whole to start talking about those collaborations, lessons learned, especially around the intellectual challenges and rewards. So we have a microphone that Laura has handy for you to raise a hand and say something about one of your interdisciplinary collaborations, and perhaps to speak to the questions we've been asking this panel up front. So Ann Ross has her hand up front.
Thank you. So one of the challenges that we've had with the forensics cluster is how do we come up with a really good interdisciplinary project that will fit an RFP? Because we have chemists, we have people that do DNA, we've got entomology. So how do we pick a project that can encompass all of that? So that's been one of our challenges.
Do people on the panel have a thought about that or an experience with that?
I guess some of the things that we end up doing is looking for larger projects. So looking for RFPs with a wider vision, not necessarily something that is narrow in scope. And in part because a lot of the stuff that we do, we can't afford it if it was a more narrow grant. I'm always amazed by how much money these experiments cost. You know, my lab consists of computers and the students that stand next to them. You know, so you know and then the difficulty in terms of the time and everything that it takes. So widening the scope has typically worked for us in a good way.
Just to pile on to that one, or Jason, did you want to?
Go ahead.
Just to pile on, I would say one thing in the cluster that I help coordinate, the visual narrative cluster, we fail a lot. I mean, we have spent just a tremendous amount of energy applying to the National Endowment for the Humanities, the American Council for Learned Societies, the National Science Foundation. Yeah, so, yeah.
I will say, you know, as a social scientist, I think there's a growing appetite for thinking about the social dimensions and the political and ethical dimensions of science and technology. And so for me, it hasn't been difficult to be seen as an asset to a project in terms of bringing a perspective, whether that's about how the research gets done, how it gets disseminated, or the kinds of policy questions that might be associated with the scientific or technological development. So I think there's a real opportunity on this campus to think about what's, you know, I mean, I always laugh a little bit when I hear that interdisciplinary is like soil science and atmospheric science. Like, ooh. I know that is interdisciplinary, but in my experience, you know, crossing the aisle between the natural and physical science and the social science and humanities is really difficult, but it can be incredibly rewarding. And so one thing to look for are those kinds of really tough collaborations where you're reaching way outside your comfort zone.
Yeah, I would say that in some ways there's a bipolar kind of thing where some of the RFPs are incredibly narrow and they are smaller typically. And then NSF and USCA as well are looking for these huge projects that you talk about. And you have to fit into those RFPs. And I think when you are in that middle ground, right, where it is the hardest to find that.
So I should preface this question by saying that I'm a computer science PhD who's now a tenured professor in the marketing department at the Polk College of Management. And so my question is, I fully buy in the interdisciplinary research is very rewarding, obviously, given my background. But how do we change the mindset within the colleges to reward people who pursue interdisciplinary research? And should it just be for those people who are tenured, right? Or should we somehow change the mindset for our colleagues for untenured faculty as well in this space? Thanks.
That's a tough one.
Yeah, it is.
But I would say, you know, I think that things are changing. You know, sometimes it seems glacial, but I do think that that things are moving. So that I really would not say that just because you're an assistant professor, you shouldn't be involved in these kind of things. I think that at our university especially, we typically have tenure decisions made within departments and within programs, but there are abilities, you know, to have an interdisciplinary tenure committee, but I think there's some room for something in between. And so I think I would say that if you were an assistant professor and you want to get involved in interdisciplinary stuff, you have to have all of that stuff laid out with your mentor committee or whoever the department head is, and make sure that there is a mutual understanding about what that's going to be when you come up for tenure.
So I can speak to that question personally. So I started in 2008. And in 2008, the number of faculty that were working on plant systems in the electrical and computer engineering was 1. Today, it's probably about 6 or so, give or take. persistence and some level of success. But success arises from persistence. So over the time that I've been here, which I was the one person working on plan systems, there have been the emergence of the first round of cluster hires. There's been the emergence of the second round of cluster hires. There's been the emergence of various training programs, interdisciplinary training programs. There's been the emergence of these interdisciplinary centers. There's been the emergence of the PSI. And now there's been the emergence of this call for fourth generation convergent engineering research centers. So, like Fred said, it's moving. It's moving in that direction. And you just have to identify good people to work with, good ideas, establish a good vision, and move forward. And at the same time, get the people in your department to understand why what you're doing is important. Because some knew, but most know now. And it's really related to a lot of the things that we've been able to do on the campus.
I think I'd want to speak specifically to your question about being junior faculty. And I think from my prior experience, before Jason, that was really important to ensure, particularly at the end of the project or towards the end when you're putting out your publications and you know that's really where you're going to get your outcomes and metrics from, that there's got to be something for everyone at the table in that context, and that the PI of the project or the management team has to ensure that it's going to be of benefit to everybody. And it's a thought on my mind with our current collaboration in terms of how you line up the outputs of those publications so that there's something that resonates for all the disciplines. And I think that would be important to junior faculty to make sure that they're still getting those metrics as they go through the tenure process.
I want to pile on because it's such an important question. From the perspective of my discipline, history, historians at NC State have been quite open to new methods. And in fact, if I think about the recent hires in my program, I was hired in 2004. I have a master's degree in environmental science. Recent colleagues come from anthropology. The digital humanities effort at NC State in the history department has relied on people having training outside of traditional historical methods. So that kind of omnivory comes rather naturally to historians. We have to be scavengers. But it's been interesting to see this department and also my dean and others embrace that kind of diversity within the new faculty. So in some ways our success, the success of our younger faculty in particular, comes from that built-in experience. And also the clusters have helped. The cluster that I'm helping to coordinate, when we hired only one person who had tenure. So two of them were straight out of graduate school, still in graduate school. So setting up the arrangements for tenure, protecting those new faculty, making sure they were going to succeed, all that got worked out in advance before the hiring process really got underway and during it.
I kind of echo a lot of what's been said. I mean, you can form collaborations at different levels. You can form huge groups, small groups, intermediate groups. But I think we see now on this campus a real spirit for developing new ideas and forming collaborations. And I think you can, surprisingly, I think it's just a question of picking up the reins and going with something. Because I think departments will want to support these things, colleges want to support these things. I mean, that's been my experience. You have an idea, you form a group of people, you have no idea where the hell you're going, okay? But you think you've got a good idea. You go out and sell it to get the support of your department head, okay, and then you start looking at the college level for support. And I think everybody will be amazed that modest amounts of money will flow to make those things happen, and that's what you can build on. Because I think departments and colleges are looking for innovation, they're looking for new ideas, and they're very supportive of to give you seed money, to get something going. So I don't think it's a question of, oh God, where am I going to get the money? I think if you put a team together, okay, and you have an idea that you believe in, I think you will be successful. But it's that first step, getting the group together and then moving forward to get that small money to get something going. And that's where the innovation will come in. And I think that's what the colleges and departments are looking for. And that's been my experience. And I see us moving more and more into that arena with the cluster hires and all that stuff. So I think the answer is we shouldn't be afraid to try new stuff. I mean, you could argue, well, if you're an assistant professor, maybe it could be a big problem. But you never put all your irons in one fire, that's for sure. But I think we will be rewarded for trying new things. That's my opinion.
Other questions? Comments? Well, I have a comment, if no one's going to raise their hand. Wait, Cressy has a question. Good. Stop me.
I like stopping you. I wanted to add something to how do you know you're really involved in interdisciplinary work. And I think it is when you realize the sacred values that you held on to and the concepts, your disciplinary concepts that other people share are not defined the same way. So you say the same thing, or you say, yeah, you think you're saying the same thing, but you mean totally different things, right? So that's one of the things I've learned in interdisciplinary work. A couple of projects that I've been involved in related to interdisciplinary work is not from research questions that are generated by us. They are generated by communities and community members, right? And so you never know what the disciplinary expertise is going to be until you get into it, right? And then you have to say, oh, we need to bring in this person or we need to bring in this group. And that's been the joy for me, right? Learning about new things I never thought I would even care about, right? But understanding in the end how they work together has been one of the best benefits of interdisciplinary work.
Matthew, I'm going to stop you too. Because I just want to comment on what you're saying. And a part of it is, that you get a group together and then you try to think about who you need to bring in. And I think there's some of that, but some of it is who comes to your door. And, I think about some of the interdisciplinary things that I'm involved in, and they could have moved in a lot of different directions depending upon who joined us. And there's such a stochasticity to how that happens. I mean, the fact that Matthew showed up in my office, probably we think because his department head said something, or that I'm doing a project on that's going to be in the museum on art and biotechnology because I was friends with somebody who's works in the libraries, and it just happened to happen. So I think there is a lot of where you look for somebody, but there's a lot of who's willing to come in that shape where you go. So I just wanted to comment on that.
Also, if I can just build on something that you said that made me think about this, is that the world isn't organized according to discipline. So we have these structures within the university, and we have our own training that's done this way. But when we go out into the world and try to engage other audiences, they're confused when you want to stay within your discipline. And so I feel like some of the opportunities I've had to do what I think of as more engaged scholarship, working with different kinds of task forces and committees that are organized around problems and challenges, I feel like I'm better prepared to contribute to those because I'm not stuck in one disciplinary way of thinking. I have the experience of having conversations across discipline, and my knowledge is broad enough that I can participate and communicate to audiences outside the university who don't expect you to be stuck in your own jargon and your own way of thinking.
I think we'll make this the last question.
No, you get the last comment though.
Yeah, so the purpose of this whole session here today is to try to make more connections within the university to help promote this. Is there something else that the university could do, or something else that the faculty could do to, Fred, you said it depends on who comes and knocks on your door. Well, how do people get motivated to come knock on Fred's door? I'm going to come knock on your door soon, but it's just, how do you, is it just this personal motivation that enables it, or is it more than that? Is it something that we could do as a community to make that more feasible or more, lower that barrier?
I'd like to respond to that because I had a conversation with Fred Wright around by the posters, and we were talking about how we do attract people who are already interested in this, and how do we get everybody else involved, and how does the university do that? And I think he recommended that we have a concert with Bono come here, and then we lock the doors. But I think that there may be something else. I mean, the question is, how do we get the people in here who are not here today, right? And I think that that's something the university could do, and we need to figure out those mechanisms so that it isn't just you happen to know somebody, but that there's something a little bit more defined.
Well, we don't have to actually have a concert with Bono. You just have to say that there is, and then when people show up. I mean, I think I sense or I see a lot of incentives in the university to work across colleges, internal grants and things like that. One area where I see a huge disincentive is in collaborative teaching. So I've been a part of a couple projects through the Genetic Engineering and Society Center, and it's really hard to figure out a way to allow two faculty from different departments or different colleges to co-teach a class. But it's those relationships where, boy, you really learn what somebody else, I mean, I see so many heads nodding, you really learn what someone else can add to thinking through a problem when you teach a whole semester with them. It's a lot of work. It's really hard. It's time consuming. But that kind of payoff would be amazing. And if there's a way to incentivize those kinds of relationships, that could be a different way to get people out of their silos.
That's it, one last thing. Greg, I think one way is to, so thus far we've talked a lot about the benefits and the joys and the intellectual satisfaction that we get from doing interdisciplinary work, but also conveying the fact that it can be frustrating, that it can be, you can have a meeting and you can spend an hour or an hour and a half talking about various things within that meeting, and you come out of it feeling like, what in the world did I just do? And sometimes that happens. And the idea is that, or conveying that to individuals and saying, well, the first time you interact in these interdisciplinary meeting, or someone asks you whether or not you want to meet and nothing comes out of it, or you feel very discouraged, understanding that that is a possibility, but you have to go through that process maybe 1, 2, 3, 5 more times to be able to actually find the right connections, or even to have the right conversation. Because that person may be the right person, but you're not speaking the same language, so thus one individual has no idea how they can contribute. Well, it's gonna take about 3 or 4 more times to actually do this. And then another way is potentially identifying individuals, targeted individuals, who can start to link people together. Because I've been in many situations where I see one person over here, I see another person over there. This person doesn't know how their research can actually influence the work that we're doing, but I see it because I have an idea of actually what's going on in those two camps. So, you can try to bring them together. So having individuals like that can potentially motivate, those types of interactions, that might be another possibility.
We hoped it would be a good conversation. It was. And I think we're...
One suggestion.
Good, we're not getting the hook.
I'll try to be quick. When I was at Duke the last year, they had a couple of things for integration and for teaching that I wanted to share. So the first was they have a risk center, or developing risk center, and the whole concept is to get different folks across the institute to attend like a monthly, they called it watering hole event, and it was just like informal after hours, like 4:30 to 6 or so, and they rotated different speakers. So they had like maybe 3 or 4 folks, just like you, give a small, 5-minute spiel about what they were doing, and then other people could get to know them better. But the risk watering hole was just like an informal gathering for risk people. And as many of you know, like risk is really a multidisciplinary topic because you have the science and you have the social science and ethics and policy, whatever. So this risk watering hole is one suggestion I had for you. And then the second one was also at Duke, they have something called the Basque Connections program, where it's a teaching, a different type of teaching system or program where they would have a class focused on a topic, but it was intentionally geared towards multidisciplinary, transdisciplinary students, and also across levels. So there was a combination of undergrads and graduate students and even postdocs there. So you have like different layers of education types, all focus on a complex issue. So the course that I was involved in, it was about looking back through the problem with CFCs and how we came to the Montreal Protocol Agreement, and then looking at climate change, which obviously is another complex multidisciplinary project. But anyway, I was just thinking that these two mechanisms could be helpful for how to get NC State like having a real mechanism for both interaction and for teaching.
Thank you for that. Those are good concrete examples of what people with small administrative budgets can accomplish. If you can, really, I'm serious, if you can buy some beer and some pizza, or maybe not beer if you're in certain colleges, you can get a lot done in terms of fostering these relationships. So thank you for those comments. I appreciate it. Our time is up. The next event is happening. I'm really grateful to our panelists. Thank you, panelists, for putting yourselves on the line in this way and starting this conversation. And thank you to the audience for your comments.
Well, we are coming to the conclusion of our program, and so we're going to have one final round of our lightning discussion. Each speaker will have 2 minutes, and then you'll have a chance to interact more at the time. So we are ready for.
Good afternoon again. This morning, for those of you who were here, in my presentation, I introduced the efforts that University Outreach and Engagement has been making to promote, connect, and support community engaged research and the scholarship of engagement at NC State. That's moving faster than I'm talking. The presentation, this presentation on our poster number 15 describes what we believe is a multidisciplinary collaboration in is a model of multidisciplinary collaboration in a primarily rural area that I and my colleagues, Chilin Pasalar with the College of Design, Duarte Morai with the College of Natural Resources, along with several other consulting faculty from animal science, vet med, agricultural sciences, and otherwise. We were engaged in this project over the past 2.5 years. The Southeast Equine Research and Education Partnership was a community-engaged participatory action research project with Isothermal Community College and the people, communities, organizations, and companies in the isothermal region of Western North Carolina. The approach we took was multidisciplinary and grounded in the scholarship of engagement. We engaged in a systematic process of partnership building, intentional and broad community engagement, and more directive research based on our particular disciplinary expertise. The goal was to build on the unique equine history, culture, and assets of the region to create a model that has the potential to enhance the regional equine-based economy in the area. What we came up with, along with the community, was a proposal for a Southeast Equine Community and Research Center, roughly based on this concept of One Health that integrates the well-being of humans, animals, and the environment. We have developed an integrated conceptual, business, and physical framework that provided a blueprint for NC State can continue to partner with the region to achieve a clear, inclusive, sustainable, and broad impacts. The center would include opportunities for university-level research, tourism, citizen education, community building, entrepreneurship, and workforce development that we are confident can provide opportunities for researchers within most, if not all, of colleges at NC State. Please stop by. Poster number 15. Since I got 2 of them over there, I might be at either one, but we welcome you.
No, wrong way. There we go. Hi, everyone. My name is Bill Rand. I'm an associate professor in the business management department in the Poole College of Management, specializing in marketing and the intersection of marketing with computer science. And I love this session. I love interdisciplinary work. I love it so much. I'm missing my beloved Spartans play basketball right now. But I really do embrace the interdisciplinary mindset. I have a background, as I mentioned, a computer science PhD. I work in marketing, and I specialize in one of my most cited publications, actually in the International Journal of Geographic Information Systems. I have interest in complex systems and agent-based modeling, but what I wanted to present to you today was the idea that I'm really interested in understanding a big interdisciplinary question, which is diffusion of information on social media. How do people find things out on social media? What do they do with that information once they have it? And how do they pass that information on to others? And I'm going to touch upon three really quick projects that we're working on here. First of all is one called Combating Social Media Bots, where we're building tools using machine learning and statistical analysis to identify bot behavior on social media. And then we're interacting with users who actually interact with those bots, trying to see why they're interacting and potentially looking at interventions that would stop them from interacting with bots again in the future. And that work, I should mention, is partially funded by LAS. As I saw Allison sitting around in the back, there she is. So that work's been great and very fruitful in that space. Another project that we're working on is understanding image-based social media. There's been a lot of research on looking at how text-based social media propagates through how people process that information, but not much on extracting image-based social media. So in this case, we're using deep learning neural nets to extract concepts from image-based social media and then see which kinds of images are more likely to be passed on in a viral sense. Finally, this is a large project I'm doing with the University of Central Florida, where they're looking at influence hierarchies, and they're trying to simulate large-scale social media and try to simulate all of Twitter, all of Reddit, all of GitHub, for instance. And we're trying to understand how one user propagates information. So if you have an interest area that you'd like to study, subject area you'd like to study with regards to social media, I'd be happy to talk to you, and I'm at poster number 20. Thank you.
Good afternoon, everyone. I'm Rohan Shirvaikar. I'm an associate professor in the Industrial and Systems Engineering Department. And for the multidisciplinary part, I have joined an associate appointment in the BME department, as well as at the center at the Comparative Medicine Institute, which I recognize some other collaborators as well. So my group works on the manufacturing of tissues and organs. And I'm going to give you an example. So some of you, if you look at, for example, the knee joint, and I've put up a few pictures there, the current state of the art for treating a lot of knee joint injuries as well as diseases involves metal and polymer implants. For some others, it involves getting grafts or transplants from human or animal cadavers. So that's where we stand currently. However, a lot of the current solutions are not optimal in the long term. They work, but they are not necessarily the best. So where this multidisciplinary field of tissue engineering comes in is you can use living cells and biomaterials to create organs that mimic actual patients that can be used for replacements. So in my group, we use techniques such as 3D bioprinting, computer-aided modeling. We do using experiment land modeling work. We study the process material structure interactions. We do some work on non-destructive quality evaluation for a lot of these things, as well as testing in vitro as well as in animal models per se. So as you can imagine, a lot of this does need collaboration across basic sciences, across engineering, but it also involves practitioners and clinicians and surgeons in this process. What you're seeing in that video up there is an example of the knee meniscus. That's a tissue or organ that several of us at NC State are working together on, including Dr. Matt Fisher from the BME department, who's also here, and that's our poster number 21. But we are using multiple approaches and working with folks across BME, across the College of Textiles, the Nonwovens Institute, to kind of make these functional organs. So I'll be happy to answer any questions at poster number 21. Thank you.
Hey everybody, I'm Marion McCord. I'm the Associate Dean for Research in the College of Natural Resources, and I come there by way of the College of Textiles and College of Engineering. So if anybody else here has been in 3 colleges, raise their hand. So I'm a poster child for multidisciplinary interactions, and today I'm going to talk about some work that I've been doing with a team that has been working together for 13 years, composed of faculty from textiles, from natural resources, and from entomology. I also want to give credit to our postdoctoral scholar, Kun Luan, who's here, and you can meet at our poster number 22. Our goals here are to, in this group, are to work on sustainable approaches to protection from insects and insect-borne diseases. So just a few of the projects that we're working on. The first one is on protective clothing. We've been funded for 6 years by the Department of Defense to develop bite-proof, non-chemical, non-insecticidal protective clothing for the military. We currently have developed a model that predicts how different textile structures will perform in terms of bite resistance and comfort, and we have an Army combat shirt that's being tested in Alaska at a couple of different bases. We've also gotten a Chancellor's Innovation Fund work to look at how we can apply that same technology to things like maternity clothing to protect women from Zika virus, et cetera. In another twist, we've been working on plant protection. We're looking at how different textile structures can be used without insecticides, mainly for the organic market, to protect plants. And we found some really cool stuff, like plants that grow under these textiles grow like gangbusters. So we're still working on understanding that with some new folks. And we're also working on a novel bed net that's funded by the Innovative Vector Control Consortium. And we're doing some field tests in Africa. So if you'd like to learn more about what we're working on, please come to poster 22.
Good afternoon. I'm here to discuss METRIC, which is a shared resource core facility for advanced measurement science. We encompass magnetic resonance, mass spectrometry, and X-ray crystallography. We provide the university with access to state-of-the-art instrumentation as well as experienced staff members, which can all be seen on the slide here. METRIC is the Molecular Education, Technology, and Research Innovation Center. In order to get across how we differ from typical core facilities, I'd like to emphasize the education, technology, and research innovation components of METRIC. In terms of education, we offer training of students and staff on our instrumentation. We also offer workshops and symposiums, one of which is coming up soon on May 22nd in NMR and X-ray crystallography. I encourage you to check our website for more information and registration information. In terms of technology, not only do we have an investment in advanced platform technologies, we also utilize Mendix, which is a cloud-based lab management system that facilitates scheduling, billing, as well as data extracts that provide us with information with how many colleges, how many departments, how many PIs we are interacting with. Lastly, I want to focus on the research innovation component of METRIC. And that goes hand in hand with NC State's motto of think and do. We're not a traditional core facility that just takes samples in and churns data out. We think critically about each and every project that comes across METRIC, and we provide high quality data to facilitate groundbreaking research throughout many departments at NC State. I encourage you to stop by my poster, number 23, and I'll introduce myself now. I'm Allison Stewart, the lab manager for METRIC. Some of my contact information can be found here, and the QR code will take us to our website, which can also direct you to me. Thank you.
Hi, everybody. I'm Julietta Shirk. I'm a landscape architect. We do everything. Water, soils, plants, social, cultural, we try to attack everything. And we're trained to work with interdisciplinary teams. I am 100% associate faculty in the horticultural science department, where I teach grading and drainage, plant ID, planting design, hand graphics, computer graphics, and construction. So I do a lot of things, so I feel like I'm a Renaissance person. But my passion is democratic design or participatory design. And I've never partnered with a social scientist, so I would like to do that. My poster today is about work I did during my sabbatical, where I worked in Mexico with an architect to train students in the methodologies that I use for participatory design that are Henry Sanoff's methodologies that are very specific, that train the students on how to empower communities to envision their own futures. That's my passion. That's what I would like to continue doing amongst all my other stuff. And I'm beginning to develop more and more questions about impacts on community and their perception of the students' work with them. And I have 30 seconds to say that I just wanted to come and meet some folks, and I see some synergies and various ones here, so I'm poster 25. Thank you.
Good afternoon, everyone. Oh, it's so loud. I'm Yuan Yao, and I'm assistant professor in the College of Natural Resource. My group developed decision support tools for industry sustainability. And specifically, we use a tool called life cycle assessment, which is a standardized method to evaluate the environmental impact of a product life cycle, starting from raw material extraction to the manufacturing, to the use phase, then to the end of life. And my group integrate LCA with different modeling tools to help people understand the environmental and economic implications of new technology in the manufacturing industry, and also optimize existing process. Here, I give the examples of 3 ongoing projects to demonstrate the interdisciplinary nature of my research. The first example is a project where we integrate the big data analytics with LCA to understand the distribution of carbon emission intensities of different products in the pulp and paper industry. And in the second project, we integrate machine learning with LCA to predict the life cycle environmental footprint of activated carbon, a material you can produce from diverse biomass. And the third project is my career project just awarded by National Science Foundation, where we integrate LCA with many modeling tools that are commonly used in other disciplines. Examples like a geographic information system and techno-economic analysis. And we use those tools to help different stakeholders understand the environmental and economic implications of producing biochar from different biomass and also using biochar in different food, energy, and water systems. So if you are scientists or engineers who are developing new science, new technology, new process, and you want to understand the potential environmental and economic implications, please come to talk to me at poster 27.
Hi, my name is Gavin Williams. I'm an associate professor in the Department of Chemistry. I've been at NC State since 2009, so this is currently my 10-year anniversary, which I'm very excited and happy about. My formal training is in the area of biochemistry and molecular biology, but after my PhD, I became much more interested in organic chemistry, and that's where I find myself today in the Department of Chemistry. The overarching goal of my research lab is to develop a genes-to-molecule synthetic pipeline that we would like to use to engineer microbes for the synthesis and diversification of secondary metabolites from other microbes and plants. So our genes-to-molecule pipeline involves characterizing and engineering genes, enzymes, enzymatic pathways, and whole living organisms. And our goal is to ultimately apply this pipeline for the manufacture and discovery of any small molecule. And so the key here is that while in the last few years, my research has focused on antibiotic synthesis and discovery, we can actually apply this pipeline to any molecule that can be genetically encoded, and it's completely agnostic towards the biological activity or application or target of that genetically encoded molecule. So we're focused on polyketides and terpenes and more recently alkaloids, but we'd really like to reach out and collaborate with other people across campus who might be interested in applications with peptides, biofuels, commodity chemicals, signaling molecules like the volatiles that we saw earlier, other antibiotics, biomaterials, defense molecules, crop protectants, herbicides, insecticides, anything you like. We'd like to work with you to access those molecules and to do new things with them. In my last few seconds, I'd also just like to mention that I'm the associate head of the Department of Chemistry. And so if I didn't mention an aspect of chemistry that you're interested in learning more about or collaborating with people, let me know. And I think I can put you in touch with people who can help. Thank you very much.
Hi, my name is Tobias Käser, or Toby, and here you see my lab. So I work in pig immunology at the Vets College, at the Vet College, in the Department of Population Health and Pathobiology. So in what we do, we want to use the pig as a model, as a large animal model for biomedical research, and we want to. So far we specialize in vaccine development. So on the right side, you see the standard animal models, what most people use to develop a vaccine. On the left side, you see the mouse. It is heavily used when you think of rather basic science. The advantages are that it's cheap, they have a huge toolbox, but the issue with mice is that they sometimes, the results obtained in mice don't translate very well to humans. So during vaccine development, before you go into clinical trials, you often use a secondary animal model. Many researchers use non-human primates. They are obviously very similar to humans, but on the downside, they are on the one side extremely expensive to work with. You have high ethical concerns, and most of these research labs are actually closing, which is now creating a bottleneck for vaccine development. So there's a huge demand for a new animal model, which can be used for translational research, and that's actually what we do. So we want to use the pig as a model to develop vaccines, and especially also to test vaccines, so that other labs who are developing all these vaccines have now a tool at hand that they can evaluate if it's actually efficacious and if it's creating an immune response. So the pig has a high similarity to humans. It's affordable to work with, and in former times, so let's say 15 years ago when I started to work with that animal model, the critique was always that we don't have enough tools. And we actually worked on that this is not the case anymore. We have now an adequate toolbox in a really biologically highly relevant animal model. So if you want to use a pig model, visit me at number 29. Oh. And then you will see all the details, what we can do with it. And that's basically it. Thank you.
Hello, my name is Tracy Ryder. I am an assistant professor in the School of Architecture in the College of Design. I'm going to talk a little bit about, some research, my research, here we go, with my partner in crime, Aaron Hipp, who is in the College of Natural Resources in Parks, Rec, and Tourism Management. So the partnership, what we're interested in looking at is the overlap of public health and the built environment. My background, architecture, we don't talk about things like health outcomes. So just using that term makes me feel very interdisciplinary from our panel, makes me happy. So we're interested in looking at how we can better use the buildings that we inhabit every day, because we spend 90% of our times indoors, to work toward actual health outcomes, and architects don't often do that a lot. So the project started, or the partnership started with a Robert Wood Johnson Foundation funded project. This is our concept model for what that looks like, looking specifically at how multifamily private developers conceptualize, strategize, implement, or looked at funding for health strategies in their projects. And so what we're interested in looking at is how do they think about health? Are they thinking about health? And how do they start to operationalize and implement those strategies? Because it's a Robert Wood Johnson Foundation grant, this is one of their models for creating a culture of health, and so we've modified it to fit our project. But what we're doing now that grant is wrapping up, we're moving into different population types and different building types. So looking at K through 12, looking at community centers, looking at affordable housing or vulnerable communities, and how these types of environments, so there's a proven relationship between home and health outcomes. When you look at schools and health outcomes, you can start to look at test scores and maybe absentee rates. But maybe if we can look at the 1+1, looking at those, how they synergize together, it could maybe be 1 + 1 = 3 or 4. And there's a lot of complexity that goes into both environments and public health. So hopefully there's a lot of opportunity for us to collaborate across all these different disciplines, anywhere from materials engineering to community outreach to education. And so that's what we're looking for. I'm at poster 30, which is conveniently across from the Designing Healthy and Resilient Communities board over there. So if you're interested, please come by and see me. Thank you for your time.
Good afternoon. My name is Christine Grant. I'm a professor in chemical and biomolecular engineering. I'm also Associate Dean of Faculty Advancement in the College of Engineering. Our poster, which you'll see coming up, is a collaboration between myself and Ashley Brown, who is a faculty member in biomedical engineering, and Olga Kakish, who is right back there. She is a postdoctoral student working in our laboratory who just finished her PhD in education. And so that's kind of our collaboration. So a quick question, how many of you have undergraduates working in your laboratories? Okay. How many of you have freshmen working in your laboratories? Okay, just a few. So this, our poster is actually about a new course that we developed called Special Topics, Research for Engineers. It's a BME course. It's a 1 credit hour course, BME 490. In the fall of last year, we had 13 students in the class, and we were only supposed to do it in the fall, but it went so well they asked us to do it again. So this semester we have 8 students in the class, and it's kind of an outgrowth of a mentoring incubator concept that I formed because I don't do active research in a laboratory anymore. In this course, the students learn how to identify a research mentor, propose a research plan, design objectives, research methods. We also had components where they had guest speakers, they toured labs, we had faculty come and present their work and get the resumes of the students as well. The outcomes from this are, because we're still in the middle of it, that over 50% of the students who took the course last fall are actually in research labs in their second semester freshman year. The next steps we'd like to see is to engage faculty across the College of Engineering, campus-wide course possibly, and share materials with the folks who are going to be teaching it in the future. So we're really excited to do this work. We actually have a grant from the National Science Foundation to do mentoring and train the trainers, so we've done some things for graduate students and postdocs in one of the ERCs that you probably heard about earlier today. So come see our poster. We are poster 31. Thank you.
Hello, my name is Lindsay McGowan. I'm here with my colleague Lena Leonchuk from the Innovation Studies Lab in the Department of Psychology. So the focus of my research is on program evaluation for large-scale team science and technology initiatives, particularly cooperative research centers and institutes. So I'm interested in using evaluation to understand, measure, and improve the processes and outcomes of cross-sector, meaning industry, university, and government, as well as cross-disciplinary initiatives and collaborations. I say cross-disciplinary rather than multidisciplinary or interdisciplinary because we know from the literature on the science of team science that disciplinary integration varies along a continuum, disciplinary collaboration varies along a continuum of integration across disciplines, and so those are points across that continuum. So these large-scale initiatives are complex. They involve a variety of stakeholder groups. They have an integrated set of objectives related to research, education, dissemination, and application to real-world problems. They need to be able to document and communicate their accomplishments, and they also need to understand what's working, what approaches to collaboration are working and not working. And so that's where program evaluation can help with telling success stories, as well as using evaluation feedback to improve outcomes. And so my group uses logic modeling and a variety of other mixed methods designs to evaluate the outcomes of these types of projects. We've used things like social network analysis, CV analysis, bibliometrics, economic impact assessments, and a variety of other things in our work with projects funded by the National Science Foundation. I'm currently the PI for the NSF IUCRC evaluation project. That's the Industry University Cooperative Research Centers program funded by the National Science Foundation. We've also used these approaches with projects funded by the USDA, the NSA, and NASA. So we would love to work with anyone who's doing large-scale collaborative team science. Our poster is number 33, so please come say hello.
Yeah, so that's, I don't have a poster. I'm Greg again. I want to thank everybody who came today and participated. I want to also thank the organizers who put this together, and also the URC for helping give us this idea to do this. I think we had a lot of really great input and ideas, and I hope you all get to meet some new people. I've met some really great people already. So I would like to offer everybody to join us for refreshments. We cannot open the beer or the wine until 5 o'clock, officially, and it's 5 seconds after 5, so it's time. So thank you all for coming, and if you have any, you're all gonna get, Laura, is this true? They're all gonna get an email. You're gonna get another email from Laura, and she's gonna ask you to give us feedback, ideas for how we might make this better for next year, or other ideas. Also, if you have anything you want to tell me about, or about ideas for how we could do this better with the Research Leadership Academy, you can talk to me or anybody else that's a member of the Research Leadership Academy here, and we can make this better for next year. So anyway, thanks again for everybody coming, and hope you get something out of it, and enjoy. Thank you.